there's a little progress bar and it was getting stuck at G earlier. Oh, no, yeah, it's working this time. Setting up your meeting for YouTube Live. Done. Redirecting to YouTube. It's stuck at G earlier. Oh, no, yeah, it's working. Yeah, I need to mute that. Obviously working. I need to tweet out the link.
Oh, cool.
Hey, Kevin.
Hi, all right?
All right, how you doing?
Good, yeah, thanks.
A skateboard.
It's a snowboard. There's two, actually. It's just on my junk behind my desk. I've literally just a box, some more bike wheels, which need to like disappear. There's my bike there as well, and just, yeah. I've not really put much stuff away. I went snowboarding ages ago, and I've still got my bindings off my board and like stuff what I haven't like done. And then there's bits of random like LED strip lights and stuff like that with the board and random crap. What I just my desk is really tidy, but my floor has just got piles of stuff around me.
Fair. My desk and my floor are untidy. I'm having to keep a check and not forget that there's people appearing in the waiting room and admitting them.
An interesting background you got.
Yeah, love it.
It's going to hit you in the head.
Yeah. That'll hurt, all right.
Joel, how's it going?
Good, thank you. Nice to see everyone here. It's the first time I've actually managed to not have prior engagements or children causing trouble.
Yeah, I've got those, but I've locked the door now, so I think it's okay.
No, I'll probably have to disappear off when the door slams and the wife screams. It will happen soon enough, I'm sure.
Fair.
I see we're seeing your right-hand screen video during the meeting. Just keep you amused if it gets boring.
Yeah, that'll work. But it won't, I can guarantee it. So now all
what does everyone think of Picard then?
Loved it. Yeah, it was awesome. It got better as it went along, gladly.
Yeah, it's finished now.
Yeah, thankfully there's a second season already ordered, isn't there? So.
Did you watch the Star Wars series?
No, The Mandalorian, is it?
Yeah, I thought it was really good, but I'm still
I've
watching
not seen it yet. I watched the latest Star Wars movie, The Rise of Skywalker or whatever it's called. That was all right.
Mm.
People are coming in now. Well, I'll introduce everybody around 10 to 7, something like that. And the normal slides and stuff, and then we'll get going around 7 o'clock with, I don't know, well, being as Simon's not actually here anywhere, then I'm assuming, Stuart, you'll be able to go first.
I can go either way, yeah.
Huh? Happy days. He's prepared. I'm going to go check my Twitter just to make sure that I've not got a message from Simon saying, oh, I've had a problem, but it doesn't look like it. Let's just double check. Yeah, no.
Daniel, Joshua, Mom's home. She wants us to ring you shopping.
Right, that's me. Back in a bit.
See you later. Just gonna grab a drink. Back in a minute.
Yes, I might do the same thing. I'll leave you with the next generation.
Yeah.
I see Adrian.
Hello, everyone.
Hey.
Hey.
Are you able to help out, Stuart, with admitting people from the waiting room? Is that
Yeah, but
Awesome.
all I see is names, so I don't have like any criteria for actually vetting
yeah.
people.
Yeah, no, that was my criteria as well. They were there. I can put people back in there if they're naughty.
Right, yeah.
You could probably do the same.
I guess the whole point is you can kick them out and then they have to sit in the waiting room, then you remember their name.
Yeah, that's the naughty step. If they do something really bad, you can remove them and then they can't log back in.
Yeah.
Not many cameras on.
Yeah, there's a setting you can enable that stops them from being able to do that. So, which is a good thing with this Zoom bombing problem.
Be nice to see some faces, though.
Yeah, I think a lot of people have probably joined the meeting and then gone to get a drink or something along those lines. Our other speaker is here. That's good news. I'm going to make him a co-host as well. Do you want to make some? Yes, there we go. Awesome.
Testing. Can you hear me?
I can.
Yes.
Great stuff. Also, respect to Philip there. I love the Blake 7 background.
Yeah.
It's probably bad or something, but I flipping love Blake 7.
I loved it. I thought the scripts were quite good. You know, obviously the effects could have been quite better, but when I was however old when I was watching it last century.
Oh, the effects on some of them are pretty shocking.
Yeah.
But, it is. I did like how it's kind of Star Wars, but unrelentingly dark.
Yeah, it's about persecution.
Well, I mean, literally everyone dies.
Well, you don't know what happened to Avon.
Fair enough. But aside from that one, and also the villains all live. It was just that sort of program.
Yeah, I didn't like the last episode. I thought it spoilt it.
Spoilers here for a 20, 30-year-old sci-fi series, but yeah, everyone dies.
No, it spoilt the series. The way it ended, that last episode seemed to be, oh, we're not going to make any more. How can we finish it?
Yeah, well, apparently it was meant to be a cliffhanger, but they never got renewed for a series 5, so there's an end to it. Although it wasn't totally out of keeping that, you know, you end that way. It was a very grim series. Game of Thrones has got nothing on Blake 7.
Not seen Game of Thrones.
They tried to do the same thing, but Blake 7, no, way darker.
All right.
Just graphics weren't as good. Cool. setup. Please no spoilers, but has anyone seen Picard yet? I haven't seen it. I have not watched a single episode, but want to.
No.
It's very good.
Oh, good.
Slow burner.
Yeah, I heard some mixed reviews of the first few episodes, but I heard it picked up a lot.
Yeah, there's a lot of scene setting going on.
Right.
No, I've just started to watch the Bill from the beginning.
The Bill?
Yeah, on YouTube.
You'll be on Casualty next.
Ah.
We've got as far as series 11.
Wow.
Well, I had started before the lockdown, so it's not just me, but it's quite good. Sort of about 25 minutes. So really, you just want to break something up.
I remember pretty good in the day. I mean, I did watch it very much, but I saw the odd episode and it was pretty good.
I watched it until it went old Bill, new Bill. Then
Okay.
I didn't like the new Bill.
Fair enough. I'm not. My knowledge isn't sufficient to know the difference.
Well, that would have been about 2004, 2005.
I don't think I was even in the country at that time.
Okay, I'll come and see. I thought I'd go somewhere else.
Oh, nice one. I've not got a microphone on this computer. I'm paranoid.
Well, we can hear you, whoever it is that hasn't got a microphone on the computer and is paranoid.
Oh no, damn it. I'm going to definitely keep my 3-year-old out. I unmuted it because I didn't think I had one. Damn. I missed the boat on all the webcams and microphones on Amazon. So yeah, I thought I was safe to talk nonsense in the background.
Well, I thought I'd stop you just in case you said something that you'd regret.
Oh.
Well, I, for one, am planning to speak nonsense for about 40 minutes to an hour shortly.
Thank you very much. If you could take care of that, that'd be great.
I've just been sharing a very silly. Can we see that? It's a silly picture that someone put up on the internet of various cartoon characters in this form, and my Indian in-law family are all having a go at it, and I've been having to explain to them who Danger Mouse is. Yeah, I couldn't quite think I could judge their reaction from here.
My big question regarding TV characters is how Sheldon Cooper coping with this environment?
I don't know who that is.
Big Bang Theory.
I started watching an episode. I didn't care for it. Maybe that's just me. Maybe that's bad of me.
I did a similar thing. I watched one where Sheldon was banging on somebody's door for the entire episode. It worked out, and I think that put me off.
Well, I got into it because I'd come out and I had the boring job of doing the ironing. So let's watch something. And I was like, first time I watched about 30 seconds of it, thought no, and went on to something else. And each time I switched on the TV, it was on. And then after watching it a few times, it actually started to make a bit more sense. And then they started showing it from the beginning. So then I watched it from the beginning.
That sounds good.
Oh, crikey, is that Picard on in the background there, Pete?
I thought, being as there was Picard talk, I'd switch from Next Generation to Picard.
There's no spoilers. There's no spoilers in this, is there?
No, it's just the intro.
Okay.
No spoilers whatsoever in that. Well, there kind of is, but not really.
Someone's just asked for a copy of the cartoon thing. I don't know how to share. There's a way to share it here.
Well, you've got if there's a link to it, you've got the chat.
I saw it on Twitter somewhere. This must be a way of doing this.
Just think we'll be experts in Zoom by the end of the.
That's true.
And never use it again.
Yeah.
Well,
One thing's
till next month.
It's quite good on resources for your machine though. Like it runs at like about 150 meg RAM and like hardly no CPU. As if you use Teams, it uses like 2 gig RAM and like 100% CPU.
Yeah, you're probably right. I mean,
Crikey.
mine's running. I've got everything open as the host, and I'm streaming to YouTube, and it's using 18% CPU and 300 meg of RAM. So
yeah, it's pretty well optimized. To be fair.
Yeah.
Is there a way to upload a photo or something?
Change it to your background, but
that doesn't quite work, does it?
No, it doesn't. You should just be able to. Well, no.
I don't think you can upload them.
Yeah, I've turned file transfers off as well, so that's not going to help.
I'll see if I can upload it to Dropbox or something.
Yeah, then you can put a link in there for sure.
So that was the view I'd out my window at the beginning of the time. They were putting optic fiber cable down. And I was just hoping they didn't think through the copper cable that was there, because I've got to wait to the 15th of May for the switchover.
Oh, that would be bad if they did knock off your existing one there.
Yeah.
Yeah. Is that just to you then, or is that to?
That's to the whole estate to doing.
Oh wow.
So at least I could wait for people.
Yeah, very envious of that. Yellow screen of death.
I actually ought to look so we see which program that's from, because it might have actually something secretive in it. I ought to have a look at some point.
Okay, slightly better copy there.
Have my front room instead.
There we go. Wow. Okay, I've stubbed a Dropbox link up for anyone that's bothered. It's a shame it's not a very good quality copy, because that actually would look quite nice on a wall somewhere.
I'm going to stick a link in the general Teams for the MVP channel and see if anybody joins from there. Kind of spamming the channel a little bit, but I won't mention everybody, and that'll help. Well, one of the benefits of doing this virtually is that I don't have to do my usual march round the corner carrying a whole heap of drinks from Tesco's up to the 4th floor of the BGSS building. So that's always nice.
When's pizza delivery coming then?
Yeah, I was speaking to somebody about that earlier. I think it was Liam. It'd be quite nice to be able to order every single person in the group a pizza to arrive at their door. But funnily enough, the recruiters who are our sponsors aren't sponsoring, mainly because recruiters are having a pretty bad time of it at the moment for obvious reasons. So, yeah. It's a shame.
Does this mean a bottle of beer's not arriving at my door then?
Yeah, keep waiting. No.
So our sponsor for .NET Southwest, IO Associates, they're setting up
Zoom's
a web.
auto transcribe feature. I'm going to download a transcription from Zoom and place it in MediaSite, YouTube, and Facebook, maybe Camtasia. And I've already done a Zoom recording, and I spoke as I typed this, and we'll see how well this syncs up. As
Cool.
Sounds
Okay.
good.
Yeah.
Yeah, somebody
Um,
was asking about transcriptions. It may have been you actually, Ron. Anyway, you were saying, Stuart.
Yeah. So IO Associates tomorrow have like a webinar they're putting on for they're hosting Mark Rendell. So if anyone's interested in that, I think it's gRPC stuff. I think it's his Visual Recode thing. So if anyone wants to sign up, you'll find it under. We've posted it on our Meetup user group, as have the Reading one and London one. So feel free if anyone's free tomorrow wants to see that, go for it.
We've got the MK. I've got their meetup tomorrow.
And DevOps Knots have also got theirs tomorrow as well.
Yeah.
Okay, big clash.
Yeah, but if you do use Zoom, then stream to YouTube and we can catch up on it at our own leisure afterwards.
Yeah, they're using their own thing. So we're .NET Southwest, we're doing one a week tomorrow, and it's going to be pretty much the same formula as this. But they're using like GoToMeetup, have their own webinar platform, and they're using that. It's interesting to see how all these platforms do and like how they kind of feel different. But
yeah, it'll be interesting to see how well this goes. Certainly, being as I've not done this before. I've joined a few, but I've never. This will be the first time I've been to a Zoom talk. So, and I'm organising it. So,
well, I feel like I've got most of the chat platforms installed on my computer now: Zoom, BlueJeans, Microsoft Teams, and I'm sure there'll be more by the end of all of this.
Yeah, there are quite a few, isn't there?
I'm actually honestly.
Sorry, go on, Simon.
You know, I don't know if anyone else is feeling the same, but I'm starting to wonder, like, is there actually any point to us going back into the office after this? I'm kind of happy with the remote work situation.
Yeah,
there's a lot of changes to the work environment. There'll be a lot of people and a lot of companies working in a different way, I think, when this is over. Because if you don't have to force your employees to be commuting and stuck in traffic and they can actually do their job, then maybe once a week physical meetup or something, and the rest of the time just remote.
Yeah.
And also, we'd be all once if we can actually start traveling, we'd be more relaxed. So you won't be spending half your day looking to see what the latest disaster is.
I'd like to do that from Spain, from my villa.
Well, to be fair, people do that at our company because we've been working remotely all the time. And like people just go when they go like see the family if they're over in like Spain or whatever, they just trip over in Spain, have like 3 days off, and then work a couple of days and then fly back. So then you can just like work anywhere, which is quite useful to be fair. It's just a bit awkward, so it's not as good as having like just like I go and work at the coffee shop sometimes so we have like a morning coffee and code thing on Monday and Wednesday. Well, we used to, where we used to sit on laptops till like dinner time together. But it's not as like productive as having like some big screens and kind of sat at a desk. But it's good to like just like kind of be able to work anywhere without any kind of like.
I feel quite fortunate that I work with cloud platforms, whereas my colleagues who work up with embedded software. So everything they have to lump these physical machines around wherever they go, whereas I just remote desktop into a cloud server.
Yeah, well, we use a bit of hardware stuff as well, but we physically just have like them on our desks. These are like lockers, well, locks for lockers. So we either kind of have the actual mobile apps to talk to these. And we pretty much just there's like Bluetooth locks with batteries in and stuff like that, and we all just get sent them. And we got different versions of them. That's why I've got like a smaller one and big one. It's quite cool. So you can do things. So you just like you just have to have more of them because you can't share them. So everybody literally has a bunch of locks at work.
No, I know. For me, my current client's about an hour and 10 minutes drive each way, and parking's a nightmare. And I just really wonder what the benefit is anymore of going in. I mean, yeah, I think completely 100% work from home forever might end up being a bit demoralizing. But
we do the thing where we meet up every like a month and a half usually at a random hotel and have a couple nights there, more for like the social aspects of like kind of like getting to know each other than actually working. So we don't usually do much work. We have like a company update. We have like kind of like some kind of team bonding things. Then we go have a meal, go to the pub, and then people with kids go to bed early because they want to like have a nice nap. And everybody who doesn't have kids just goes out partying in town. So, which works quite well, and you get to know people a lot better than just like I've worked at 3 companies remote now, and the one previously, I only met up with them once in the office, and that's because half of them in France as well.
Partying in town. Oh yeah, I remember those days.
But you don't get to know it like people that much as like if you meet up every month or so. People get a bit more personal about things.
If you've not used Zoom before, in the top right-hand corner of your screen, there'll be a little thing that you can switch to a gallery view for everybody's face rather than speaker view. And I find that tends to be a little bit better, a bit more organic rather than it switching constantly between a big picture of somebody's face.
This is the pop-out version of it when I was on this last. So when I used this last, it popped the actual people's faces out onto another actual pane.
All right.
You have to be in full screen.
Okay, is that why?
And speaker view, I think, unless someone's sharing their screen, in which case you then get a divider and you can like drag it across.
You can then go in the option and untick the side by side and get the pop out if they are sharing the screen. It's really complicated for no apparent reason.
Excellent.
Too many options.
Well, how many have we got now?
35 people. It's good.
Crikey.
I think we had 65 registered on Meetup. So it must be traffic that's delaying people.
Yes, that's definitely one thing I'm not missing.
No. Shame we're not commuting now because it would be easy.
Yeah.
Petrol's cheap.
Is it? I haven't been out.
Yeah, apparently it's 101 in some places now. So
wow.
Really? It was 103 the other day. It's ridiculous.
Oh, they are. Yeah, it was 125 last time I checked. I'm sure. So
I did have a traffic jam outside my house the other day. Why this afternoon?
Really?
Yeah. There's some people. My neighbour's got cancer, so it was I think it was his sister-in-law and brother came to deliver some food, and while they were here, the dustman turned up, and of course they just blocked the whole road. So they had to wait for the dustman to do all their business before they could leave. So I did traffic jam with 2 vehicles.
Hardcore.
Oh. Don't mind me, just realised I plugged the proper microphone in.
Testing.
I can hear you.
There. You guys still hearing me?
Yep.
Does that sound any better?
No, same.
Oh.
I think, you weren't speaking for all that long. It doesn't sound bad. Let's put it that way. It sounds perfectly fine.
I've actually just shifted to the proper mic now.
Ah, yes. Well, being as it's now gone past 10:02, I think we'll get going. I'm going to share my screen. Now, what I'm going to do at this point is I'm going to mute everybody, but I'm only going to do that after I finish speaking, just in case there's any problems, because obviously I've not done this before, so I just need to make sure that I'm not getting it all wrong. So everybody should be able to speak, but just obviously be quiet for now. So if I share my screen and share this, then everybody should be able to see my slides, all being well.
Yep.
Good. So this is the first virtual .NET Knots that we've ever had, that I've ever done. So You can expect something to go wrong along the way somewhere, but as long as I don't cut everybody off, then I think everything else we should be able to get over. If you are over on YouTube, then you can feel free to write in the comments on YouTube, and I'll try and check them every now and again. But the predominance of this meeting is going to be in Zoom. And I think that's probably going to be the way we're going to have it going forwards as well. As I say, when we get going with the speakers, I'll mute everybody's microphone. But if you've got any questions, then go ahead, write them in the chat. And then once the speakers have finished speaking, then we'll go through the questions and either the speakers themselves can read them, or I'll moderate them and read them out if they've missed any. Onwards from there, nobody else will be able to share their screen because I've turned that off for everybody. So that saves this problem of Zoom bombing, which you may or may not have heard of, where unscrupulous people join public Zoom meetings like this and start sharing stuff that we really don't want to see. So hopefully with the addition of the password that you've had to come through or via the direct link and those various different measures, then we should be okay. So with all of that aside, do be nice to each other. We're going through a pretty difficult time as a world at the moment, so be nice to everybody, but other than that, enjoy yourselves. So I can't remember if I've actually got rid of a load of the slides out of this, but normally we would be sponsored by Cordius, and in a physical meeting we definitely would be. So we still like to thank them, even though they're not on this slide, because they're not sponsoring the virtual ones, because they're just being careful, like all recruiters should be at the moment. But we are still sponsored by Stickers and JetBrains, and my company, PJG Creations, are sponsoring the Zoom meeting. So I've been and bought the Pro Zoom license for that, and I'm organising it all. So that's where that has come from. So tonight we've got Simon Pater and Stuart Lang. Stuart's already said he's going to go first, Simon, so I hope you don't mind. But we've got Simon doing C# for the Truly Lazy. Actually, there's about 6 different versions I've put of that title, all of which I think are wrong. So Simon will when he actually comes on, I'm sure. And then Stuart's talking about async in C#. So it's going to be an interesting couple of topics there. Upcoming meetups normally would have loads of these, but there's only next month's .NET Knots. So we should have Penny Coventry and Steve Collins. In fact, I think Steve's actually on this meeting, listening to it, in fact, while he's on a walk. But I don't know what either of those 2 people are going to speak about, but I'm sure it'll be good either way. And then tomorrow night, as I mentioned, some of you may have heard, DevOps Knots. They've got a virtual meetup as well about Azure DevOps and Wars Don't Work from ACE speakers. So I'll be over on that one as well, helping out. So do join. And other than that, I am going to switch back here, and then Stuart can share his screen and get going with his talk if he likes. Probably, if you want to give it a couple of minutes, Stuart, if people want to go and get a drink or go for a toilet break or anything like that, now would be the time before we get going. And I'm now also going to mute everyone's microphone, and at the end I will unmute it. And feel free to put any questions in the chat.
Hi, Ted.
So I've unmuted you, Stuart, and I'm also going to unmute Simon.
Cool.
In fact, yeah, there we are. Oops, unmute. There. So we should be the only people, and then we'll get going in just a couple of minutes' time.
Cool, yeah, just let me know, and yeah, ready to go.
Feeling very privileged, although do you actually need me to be able to speak at the moment?
No, but I'm relying on the speaker that's not speaking to help moderate, so you can shout out if you say any, if you see anything, or if you want to get involved. Then I think it's a good idea to keep both of you unmuted. I'll trust you to. You can mute yourself later if you like, but if I mute everybody, then you can't unmute yourself. So I've unmuted you, so you can do what you like. But
I think my wife would like the ability to mute me.
yeah, I think you might be right. Yeah. Well, actually, it's our 2 children that need muting at the minute.
Oh, Christ. Yeah.
4 and 7 and screaming.
Oh, mine are 4 and 6, similar.
Yeah. Yeah, where are the toilets? Fire exits are that way. And pizza is whenever you order it for yourself. Social distancing.
Sure. Oh, for the record, the talk is called Hacking C# Development for the Truly Lazy.
Thank you. Yeah. You need a bit.ly for that talk title.
A what?
A bit.ly for that talk title.
What's that?
As in a URL shortener for your talk.
Okay. I had to be talked down from calling it Codex Osiensis, which is Latin for lazy coder.
Oh, that's good. You can have
It's
a
the
subtitle.
sort. It's the sort of pun that only I appreciate because I'm a nerd.
Good. All right. If you want to get started, Stuart, I think we've probably got pretty much everybody here. I mean, we started at 6:30, so we will get going. Questions in the Zoom chat.
Cool. Yeah, so thanks everyone for joining. This talk is on async in C#. It's kind of evolved from an older talk I've done, going into some of the pitfalls in C#, but I've also added some of the newer things that have come out around .NET Core 3 and C# 8. So just a little about me. That's my face, and this is my face as well. So if you're new to Zoom, by the way, this may be the time to switch it to speaker view, because then you'll have hopefully side-by-side slides and presenter. And you can, I think there's like a slider. If you've got it full screen, you can, when there's code on screen, you can make that bigger, you can make me smaller and vice versa. I blog at Stuart.dev, and that's where you can find all my other social media bits and bobs if you want to follow me. Southwest Meetup happening, virtual meetup a week tomorrow with Steve Collins, or Steve Talks Code as he's otherwise known, which I think you mentioned, Peter, that you've got the following month. So if you want an early preview, I don't know if he's doing the same talk. I think he's got a couple of talks, so maybe it's a different one. But yeah, you're all more than welcome to come to that one. So good. We also got I think I saw Jason join. He's another one of the organizers in the attendees here. So just to run over what I'm going to talk about, I'm going to start really right from basics, like just why we even care about async, how it works. And then I'm going to look at some of the guidance that's come out now, and looking at some of the do's and don'ts, and including sort of deep dives into some of the sort of gnarly areas of async. And then finally, I'm going to do a code demo around some of the new bits in C#, including async streams and channels. And if anyone has any questions as I go, if they put them in the chat, then Peter or Simon can interject and ask the questions, and I can answer them as we go, or at the end, when all our mics are on mute, you can just go at me. So I'm going to start with why do we even care about async? So basically, async and await in C# is just about not blocking when we're doing some long-running work, so just not blocking a thread. And so, for example, if we have a desktop application with a button on it, and on clicking that button, we make some HTTP call, for example, if we're blocking the thread while we're making that HTTP call, if that's the UI thread, then we lock up the UI for that application, and that's like the worst thing we can do in a UI app. And so what we often end up doing in a UI app is sort of spinning up threads just to get off the current UI thread. And in a UI app, that's totally fine, and we're happy to kind of spin up threads just to get away from that the UI thread. But on the server-side application, for example, ASP.NET or ASP.NET Core, that's the opposite of what we want to do. We want to use as few threads as possible. Threads are a precious resource when we have a web server. And so if we're doing things optimally, what we would want is every web request that comes in, if it's all possible, we'd want to use at most one thread. But for most of the time, I want to use no threads. So if we're doing something where we're talking to SQL Server or some HTTP API or writing files to disk, these are long-running things. These are IO-bound things. Hopefully, we can use no threads at all there. And that's the kind of goal of async and await, is to be able to scale well beyond what you would be if you were just tied to one thread per web request. And so if we're using our thread pools efficiently and just borrowing threads as we need them, we can scale way beyond what we would have. But if those two scenarios aren't your sort of immediate goal in the project you're working on, it kind of still matters, because as we're going to look at as we go through this talk, if you do async, if you do it wrong, it's worse than not doing it at all. So if you kind of abuse async code, and you'll end up kind of with worse performance characteristics than if you just use synchronous code. So regardless of whether or not you need these benefits, you kind of, because async's ubiquitous now, you kind of you have to know about it. You have to do it right, basically. So I'm going to start very quickly with how it works, just as a refresher. So apologies for those who already know this inside out. But here we have an async method, really simple, and it just writes to the console, writes out A, B, and C with pauses in between. And we await this async method. And if you, when I share these slides, I've got a link here that goes into sharplabs.io where this code is, and you can see what the compiler generates. So the compiler generates a whole bunch of code under the hood that turns this method into a class, and it models it as a state machine. And so you can kind of look at what it does. You can see there's no black magic involved. But in terms of what happens at runtime, I said we await this async method, and that's not really a thing. You don't await a method, you await a task. So we can always mentally rewrite this code as we are invoking a method that returns a task, and then we await that task. So to kind of step through what happens here, we invoke this method, and immediately on that same thread that we were on, we come in and we write to the console A in this case. So no magic happens, basically. Some other languages, async workflows are kind of deferred until you explicitly start them, but in C#, they're kind of hot. They start immediately, basically. And now we await this task delay, and task delay returns us a task. And if that task is already completed, we actually just carry on synchronously. We just carry on the same thread. But as I guess you can, as you would expect, task delay 100 is going to be incomplete at the point we await it. So we're awaiting an incomplete task, and that's when the magic happens. So at that point, we return an incomplete task. And on the very next line here, we await that task. And again, we're awaiting an incomplete task. And so we return that again. And so this is called stack unwinding. And that will keep happening until you get to, let's say, the very top of the stack of a thread pool thread. And then that will be yielded back into the thread pool. So that's kind of how it works. And then the other important thing, of course, is when we await an incomplete task, the rest of the method here, which is called the continuation, that gets scheduled to run. And I'm going to simplify it for now and just say that it gets scheduled to run on the default task scheduler, which will be the thread pool. We'll get into more detail later. Yeah, so at some point, the rest of the method will end up running once that task delay task completes. And so it seems quite simple. And the problem is that async and await is an abstraction. We're being abstracted away from some detail. And with abstractions, you kind of have really simple abstractions, and think of that as like a one-to-one mapping of like a class and an interface. It's just a very simple decoupling. It's not particularly a useful abstraction, and it doesn't offer us much, but it's kind of safe. It's kind of like, it's not doing lots of magic for us. And then on the other side of the scale, we've got really powerful abstractions, things like ORMs, things that are kind of hiding whole technologies and concepts from us. So for example, an ORM might promise to hide SQL from us. Like, the selling point may be that we don't need to know SQL. However, as we probably have come to know, sometimes that detail leaks through. So maybe when you get to production, certain queries aren't scaling right, and suddenly you now need to know about SQL. So that implementation detail that you're being kind of protected from or abstracted away from can bleed through and come to bite you in production. And the thing with async and await, I feel, is that it's somewhere in the middle here. It's not black magic, although it is very powerful and very useful. And the problem is, I think, is that it leads you into a false sense of security. So we write async code, maybe it compiles, and maybe it runs even. But then we get into production, and some of the detail under the hood starts to leak through and bite us. And that leads to a number of problems. And here's a really good quote from Kathleen Dollard many years back on .NET Rocks, before she joined Microsoft. This is an observation she had. At the time, she was going to various big clients with very large development teams with really smart developers, and that's what really struck her. As she was seeing that really smart developers were writing, in her words, really bad async code, and she just found it quite remarkable. And this is kind of what I see as well. Even like some of the best developers out there, I have a massive amount of respect for, get this stuff wrong. Like we all get this stuff wrong, and so I think there are problems there, and that's kind of what inspired me to kind of start putting together this talk originally. But when I did start to put together this talk, this was way before there was this guidance. So if you take away one thing from the first half of this talk, it's that this exists. And so this was put together by David Fowler, who's a principal engineer on the ASP.NET Core team. And it's just general guidance around async. And it's got lots of concrete examples of do's and don'ts, and more importantly, why you do and don't do certain things. And as you can see here, it's been contributed now by many people across the community. So it's a really good resource. And I've got the link here if you need it. But I'm going to start by just going through some of these bits of guidance. Some of them I think are really well known, and some of them are lesser well known. So I hope I've picked out like a good mix of stuff. And this is probably, if we know one thing about async, I think this is the one thing we do know, which is async is viral, meaning that if you've got an async method you need to call, then you yourself need to be in an async method to await it. If you don't, you're blocking that the current thread, and so you're kind of losing the benefit. But worse than that, it's worse than if you just wrote the synchronous counterpart, because you're parking that thread waiting for the thing to complete. But that async work will also itself borrow a thread from the thread pool as it needs to. So you'll be using at least one thread, if not more. And we'll see later on, there's other problems you can run into, like async deadlocks. And so one of the problems with the guidance is the fixes are always really easy, because it's just like noddy code, right? So the fix in this case was to just make the method async and await the thing, right? So you should always await asynchronous methods. But of course, the problem we have in reality is that often we find ourselves in places where we feel we can't await things. We're in synchronous methods, and we feel like we can't change them. And those scenarios are reducing less and less. I remember years back, there were places in the framework you just couldn't. I mean, even recently in a dispose method, you couldn't use async, and now we have dispose async with iasync disposable in C#8 and .NET Core 3. So those places are becoming less and less. But there's still some places, you know, sometimes we have third-party code or code from another team that aren't willing to make an interface async for us, and we're kind of forced down a bad route. And we're going to drill into later some of the problems that can come out from that. Here's another one I think that's quite well known. This is async void, and basically don't do it. If you've got an async void method, it's kind of fire and forget by nature. You can't await the result of it. And importantly, no one can ever kind of witness the exceptions that come out from it. So if this code here, this async method throws an exception, nothing's going to be able to see it unless you have I think it's like a task unhandled exception handle, like a global registered event handler thing. But this can take down your whole application. So you want to avoid this. The only scenario where you're kind of forced into this is when you have event handlers in, for example, WPF or WinForms, or I think Xamarin, in which case you're kind of stuck doing async void. The fix here, again, it's noddy code. So the fix in the guidance was just, well, make it return a task. But there's a really nice library down here. And it's also just a single C# file you can bring in from Brandon here, who's a Microsoft developer advocate. And it's just a really simple extension method on task that lets you do fire and forget in a more safe manner in those cases where you're doing event handlers. So that's a nice one to jump off and have a look at. Okay, so I start with the really simple ones, but here's some more nuanced, some more complicated ones that hopefully is news to people. When we have async methods, a lot of them have support for cancellation tokens. So we pass in a cancellation token, we can signal that we want the thing to cancel. And that's called cooperative cancellation. The implementation would choose to look at that cancellation token, and if it's canceled, then stop what it's doing. But sometimes methods don't take a cancellation token, or perhaps they do, but they don't respect it. And so we might want to ourselves kind of add our own cancellation that kind of forces it in. And here's how you might do it. You might have an extension method on task that takes a cancellation token, and this code here will start a task that never ends basically, but takes in a cancellation token. So when we cancel, that task stops. And all we do here is we task when any against the actual original task. We kind of race them, and if that delayed / cancelled task wins, then we've cancelled it, and we throw an operation cancel exception. Now the problem with this code is really not easy to see, but in this task delay here, it registers a cancellation registration callback. I forget the name of it exactly, but basically there's a callback on this cancellation token that's internally registered in this task delay, and that thing needs to be disposed at some point. It needs to be cleaned up, and because this task never completes, in the case where we don't cancel it, that registration never gets disposed of. So we kind of leak memory here. And so if you want to do this more properly and not have that leak, you would add in, you change it like this basically. So here we just changed that task delay out for a task completion source, and explicitly done the callback here, the registration. So when the cancellation token is fired, we'll then set the result of this task. And then the code from here onward is exactly the same. So we're still racing two tasks off against each other. But the big difference here is we've got this using keyword here. So we are disposing of that registration, so we don't leak anything. And so this is better. So if you need this, you'll find this exact snippet is in that guidance markdown file. So feel free to go off and bring it into your project. Another similar thing is you might want to have a timeout. So you might have a task, you might want to do like dot with timeout or dot timeout after here. And similarly, there's an issue with this as well that's really not obvious. And that is that we have this task delay, and let's say we're putting a timeout on something for like 5 minutes, but in reality it takes like a few milliseconds. If we've got a high throughput system, we may be doing a lot of these timeouts, and task delay internally uses .NET timers, and inside, like the internals of .NET timers use a thing called a timer queue, and basically you can flood that thing if you have too many timers in flight. So I have to put my hands up and say I've never seen this in production, but David Fowler and the team at Microsoft have seen customers report this. So this is a thing that can happen. So what you want to do really is you want to cancel those tasks when you know you're done. And so the fix for this is to create a cancellation token source and then pass that into the delay task. And then you know that whenever you leave this block of code, that task will cancel, and then the timer queue won't get flooded, basically. So again, this is a nice snippet. Feel free to pull it into your project. Another kind of hidden gotcha, and you might know this if you've upgraded to ASP.NET Core 3 or newer, you might see an exception saying synchronous IO exception. I can't remember the name of it. But you may have code like this, where you have a stream reader, stream writer, or just some stream code, and then in a using block. And here it looks like we're doing everything asynchronously. We have write async, but unfortunately the dispose method is synchronous. And in the dispose method, it's going to call flush async, but it can't do it asynchronously. It has the block on it, and that's called sync over async, which is bad. And in .NET Core 3, or I should say in ASP.NET Core 3, they changed it so that it would throw an exception if it detected that. So to fix this, quite simply, you just add an explicit flush async yourself, so that when it comes to that dispose method here, the implicit dispose at the end of this using block, it has nothing to do, so it doesn't do that blocking over async. But this is actually improved in C# 8. So we now have idisposable async. No, try that again. Async disposable, which has a dispose async method. And C# 8 lets you do await using, as we see here. And what that'll do is, instead of calling dispose, it will call asynchronously dispose async, which will await that flush async and not do that sync over async badness. But also, there's another C# 8 feature that I think is quite nice, and that is using declarations. And this will split some people. Some people hate this, and feel free to hate on it, but I like it. So here we write it as await using var, which is a bit of a mouthful. And that way we've done the declaration of this variable, and we've implicitly said use the current scope that I'm in. So the dispose async will actually be called at the end of this brace here. And so I really like this because with C# 8, you've got not only better behavior, but it actually reads better as well. So you've got less visual noise there. So you kind of, it's win-win basically. So I like it, but feel free to hate on it all you like. Okay, so another one, and this is guidance that has been given one way and has reversed. So, and again, you may have heard of this, but when we have a, here's the other version, when we have an async method that just returns the result of another async method, it's just returning that task out. Sometimes the guidance in the past has been to what we say elide the await keyword. So that is take the async keyword out and don't await it, just return it. And the argument behind this originally was this is more performant, and since then in .NET Core there's been performance improvements made to how much this allocates. And so this allocates less than it did before. So it's really less of a concern, but there's a few problems with this version of the code where you don't await it. One of the problems is if you, it's not very refactor friendly. So if you wrap this in a try catch block, you're probably not going to catch the exceptions that you think you're going to catch. The odds are that you won't see exceptions after the first await. I'm going to get into more detail and some of the stuff, but yeah, it's not very refactor friendly as well. If you have like a using block, because of the deferred execution nature of tasks, again, you'll probably get is it object disposed exception? You'll probably get those. And the other problem as well with this, and it's not really a problem, it's just a quirk of this. When you return a task from a method that isn't async, there's actually two ways you can receive an exception. You can get an exception in trying to return the task, and you can get an exception wrapped in the task itself, which is the much more common scenario. When you mark a method as async, you're only ever going to get that second scenario. You're only going to get you're always going to get a task back, guaranteed, and that task may contain an exception. And in most cases, when you're consuming this task, that isn't going to matter too much. But there are times when it does matter. Maybe the code, the way that air handling your code works, cares about that. And if it does, then when you have the explicit await keyword in there, this method behaves far more, it's more predictable. So that's another reason. And for those reasons, the nano optimization of eliding the await keyword just isn't worth it. But there's still people out there that are recommending it the other way. So, I won't be too dogmatic about it, but I think the guidance says this is the way to go, and I agree for what it's worth. Zoom's just complaining about connection here. If it drops out, tell me and I can repeat stuff.
I'm hearing you just fine.
Few. Okay. Yeah, because I feel like I'm on my own here, just like talking. And if I drop off here, I'm not going to know until like until I hit the end.
Oh, I'll make sure you know. You are the connection is breaking every now and again, but it's generally stable. It's okay.
Okay. Let me know if it's broken for too long or something.
Yeah, no worries.
Thanks. Here's another one. Task result. I still see this. I thought this was well known, but it clearly isn't because I still see it today. If you want to return something, in a task where you've already got the value of it, then task.from result is the way to do it. I still see people doing task.run. It's kind of saying go off and run on a separate thread pool thread this work, and then that will immediately complete and come back. It's just this is an inefficiency because whoever awaits this is going to now be awaiting an incomplete task rather than completed one, and they cannot. There's an optimization opportunity lost and all the callbacks for async, and it's just just use task.from result. It's an easy one. You should definitely go through your code and tidy that up if you've got cases of it. And if you're using value task, I'm not going to touch on value tasks today. There's a really good blog post by Stephen Cleary on this just over the weekend on this. I won't be touching on value task, but if you need to return a result in value task, you just use the constructor. There's no value task.from result. Task completion source. So here's another lesser known tip. So task completion source, you often use it when you want to provide something in a sort of taskified way where it previously didn't support tasks. So in this example here, there's some callback that happens, but someone's decided I want to wrap this up in a taskified method. And so you have a task completion source, and you have this task completion source dot set result where you kind of signal the completion of the task. And you might expect that the way this works is you signal the completion of the task, and the person that awaits this task then kind of witnesses the completing of that task and then asynchronously runs the continuation. But what actually happens here is at the point set result is called, the continuation is actually run in line wherever this happens to be. So if this was like on some random thread setting the result here, it would actually run the continuation. So it's really just not what you'd expect at all. And so this is just a really terrible default for the task completion source API. And so you should just go through and replace any usage of it with this constructor where you have the run continuation asynchronously. I did this in a code base recently. I had like 8 occurrences of it in a Xamarin project. It fixed one bug, and then in all the other places, I saw no change in behavior. But I'm happier because it now behaves in a way that is sane. And so the recommendation is you almost never need the other version of it, the default version. You probably want to go through and use this instead.
Stuart?
Yes.
I'm just going to turn your video off and just see if it helps with the... I'm hoping, yeah, good.
Cool.
I've only stopped your video. Your slides are still running, so
Okay.
carry on. Apologies.
Thank you. So it goes. So here's another one. So I said earlier that for kind of efficient running of your application, you kind of want to just borrow people, use them briefly, and put them back. And so what you don't want to do is you don't want to block on a thread pool thread. This is kind of bad practice. So in this example, there's a blocking collection, and blocking collections, the common usage pattern for blocking collection is to kind of block basically, but for long periods of time. And so this is the sort of thing you're tempted to, at the start of your application, perhaps do task.run. And this is the sort of thing where you wouldn't want to use a thread pool thread for that. You wouldn't want to use task.run. And so the recommendation is to just use a dedicated thread. So you can use new thread in this case, which doesn't seem as modern looking, or you can still use task.factory.start new, and there's an option that's called long running, and you can use that. But that API is a bit more easy to get wrong because people often pass in async delegates, and it doesn't support async delegates. So that's why in this sample it's just new thread. But this is what you want to do rather than blocking on thread pull threads knowingly. It's still telling me that the connection's wobbly, but we'll see.
I'm still hearing you fine.
Phew. Okay. So again, this is probably the most prominent one or the most common one that people know about, but it still happens, which is don't use .wait or .result. And there's also .getAwaiter.getResult, which is kind of an alternative to these two. If you use that version, then you get, if there's any exceptions, you get those exceptions just as if you had awaited it. Whereas when you use .result or .wait, you get aggregate exception. So that's probably the one to use over these, but all of them, they all block. And this is called sync over async. And you don't do this, as I've said, because you're going to be using more than one thread. And so you've kind of inverted the whole goal of async. The other problem is you get something called async deadlock, so you can do. And so I'm just going to explore that briefly. And so to understand deadlocks, you have to know what a synchronization context is. And there's basically 3 camps of people, I think. You've either never heard of this, you've heard of it and you think you know what it does, or you've heard of it and you know exactly what it does. I find most people are in one of the first 2 camps. I usually do a show of hands here, but that'll be time consuming. So just be aware of which camp you're in, and hopefully by the end of it, you'll kind of understand completely what it does. But basically, the problem it solves is when async was introduced to .NET, we already had application models out there. And you have, for example, UI applications. And if you were sequentially writing some UI code that was updating a control and then doing a HTTP call and awaiting it, if you came back on a thread pull thread and then updated another control, that wouldn't work. You need to be on a UI thread to be able to update controls in, for example, WinForms. And the same is true for ASP.NET. If you were writing code in a controller, it turns out that HTTP context.current is backed by thread local state. So if you started switching threads, that code just wouldn't work. So they needed some mechanism of being able to add a hook into the async sort of state machine. And so synchronization context is a way of adding that sort of a dabble of synchronization to otherwise asynchronous code. So this is that async method I talked about earlier. And I deliberately omitted a piece of information, which is when you await an incomplete task, the current synchronization context is captured. So synchronization context is a class, and it's kind of like a static property. It's an ambient state. And if you have a synchronization context, and it depends on what application type you're running. So for example, a console app doesn't have a synchronization context, but let's say we're in ASP.NET, then it does. So if you have a synchronization context and we await an incomplete task, then it's captured. And the continuation is then posted to that synchronization context when it continues. And just to give it, just to be a bit more concrete about that. Oh, and I think we've all seen configure false, but if you haven't, you can control that behavior and disable it with .configure false. The false is continue on captured context, and by default, as I said, the synchronization text is captured, but with this version, you're explicitly saying don't capture it. This is what synchronization context actually looks like. As I said, it's a class. It has a static method called property called current, so you can always look at it and see what that current one is, and you can set it explicit yourself. Although you probably never do this in actual code. And importantly, it has a post method on it, and this is what happens once your task completes and your continuation is about to run it. That delegate, that continuation, is passed into post, and post can decide what to do with it. So, for example, if we look at some implementations here. In the WPF version, the dispatcher synchronization context, it will take that delegate and just dispatch it. But in ASP.NET, it doesn't need to dispatch it anywhere. it will invoke it as a regular callback, but before doing so, it would have restored HTTP context like current. And so here are just some examples. The default one is just that class we saw here, synchronization context. The other ones will inherit from it and just override that post method. And this is important for understanding deadlocks, because these synchronization contexts have different behaviors. And so I already talked about that first behavior, which is, does the callback delegate, does that need to execute on a particular thread? And for UI applications, they do. The reason I call this out is because a lot of people talk about configure false in the context of a performance optimization trick. They say it's to avoid the performance penalty of switching threads. When they say that, they're only thinking about these scenarios, these UI scenarios. They're not thinking more generally. Configure false is about saying you don't need to capture that current context. And so on ASP.NET, for example, it's nothing to do with threads. I just think that's the wrong way of framing this whole thing. But the important thing to understand for deadlocks is that is this column here, and this is do those callbacks, do they need to run? Can they run concurrently, or can only one run at a time? And for the default one, so let's say we have a console application, lots of these callbacks can run concurrently. But with any of the other synchronization contexts here, for example, ASP.NET or WPF or whatever, only one can run at once. And that creates a problem for us, especially when we do irresponsible things like blocking async code, or sync over async as it's known. We can run into a deadlock. And so to illustrate this, I created a little ASP.NET application to kind of visualize this, and I hope I can explain it with this visualization. So here's some code on the left, and it's an action method, and it has this local function called countdown async. And all it does is recursively awaits itself, and you pass in a number like 5, and it counts down to 1 with this delay in the middle. And so it's pretty pointless. But I wanted to do this because I think our code has multiple layers of async code. We're waiting all the way down the stack, so it's important to visualize it, I think, like this. And I've also, you can see, added this async trace, and this will capture on entry and exit. It'll capture a number of things. It'll capture the current thread, the synchronization context, the method name, and that means I can visualize it in the view. And so here's what it looks like. And so I was to show how deep in the call stack it is. This is the name it's in. And so you can see that in ASP.NET, there's a synchronization context. It's flowed by default because we've not used configure false anywhere. And we can see that the thread ID is the same all the way into each of these methods because the entry of each of these async methods are completely synchronous. But as soon as we start to await incomplete tasks like task delay, we start jumping back on different thread pool threads and then completing on a totally different thread pool thread. Now, what happens when we do things like .result in a scenario where we have a synchronization context like this is we're going to block this thread. And as I said, this is bad for a number of reasons, but for our purpose here, it's bad because the thread, well, this code is currently executing in the current synchronization context. So we've got this delegate that's parked here on result. It's currently executing this synchronization context, but inside of it, it's we've awaited this task here, and the continuation has been posted to the same synchronization context. So it gets queued up behind this result, but this result will only ever complete once this method completes, which it can't because of the queued up callback here. So you can see that we're going to get a deadlock here. And in fact, we look at the result, kablamo. And what actually happens in reality is that the person who hit this web page, it will just hang, the web request starts but never completes. So it's pretty bad. I'm just going to show you more variants of this. I'm going to run through quite quickly, just to kind of really get an understanding of it. But here, again, we've done .result, which is bad, of course. But we've used configure false everywhere in this async method. And if we were to see the results of that, you can see that the synchronization context is null. at the point we start awaiting stuff here. And I just want to illustrate, you can see here that the bad thing, which is thread 9, was in use the whole time here, all the way through this. But at the same time, these 4 threads were borrowed. So we're always using 1 or 2 threads as opposed to 0 or 1 threads. So this isn't very scalable, especially if you've got multiple layers of this stuff. It quickly gets out of hand, and you can run into a situation called thread pool starvation. And at that point, all bets are off. Like, you're not gonna be able to serve any more web requests. Here's the same method again. We're still doing .result, which is obviously bad. And we're awaiting task delay, and we've got configure wait false at the top, but we haven't put configure wait false here or here. And it may surprise you to know that this also works. And that's because at the point we await here, this configure wait false, the very next line, we've kind of lost that synchronization context. We said we don't need to capture it. And at this point, we can't deadlock that synchronization context. But if I have the same code and everything here is the same, except that value has changed from 100 to 0. And in this scenario, it blows up. And that's because configure wait false doesn't say you must get rid of the synchronization context. It says the opposite. It says you don't need to capture it. But in this case, task delay 0 is actually a completed task. So when we await a completed task, we just completely synchronously carry on. And at that point, we still are running within our synchronization context. And so we haven't shaken it off. And so here we deadlock. And that may seem like a contrived example, except it's really not, because if you think about where you may be using async code, you may have a library that gets a value asynchronously, like gets a value from a HTTP server. And maybe you want to cache that value. That makes sense. Well, on the first request, it will be doing it asynchronously. And on the second request, when you hit the cache, you'll be getting a completed task. And so suddenly your synchronization context in your code starts to flow further. It's not deterministic. And that means that these deadlocks, they can hide in all sorts of places. And you may not witness them on the first run. And that makes this whole problem really hard. So this is why in these cases, basically, just rule number 1 is never block where you don't need to, because you kind of have to start thinking about this problem. And rule 2 is if you are doing this, and again you shouldn't, then configure wait false is your friend. However, I will say that if you are in the space of doing this, you've got a problem. So I generally don't go around recommending configure wait false, because I think that it just doesn't solve, like, you just need to not block an async code, basically. Otherwise, you're in a whole world of pain. Here's another example. You can explicitly set the synchronization context yourself, and that works. What have we done here? Oh, this is an interesting one. So here we have the blocking code, the countdown async.result, and we have the offending code that we know will deadlock. But we're wrapping the whole thing in a task.run. And it turns out this does work. And the reason I highlight this is because sometimes people use task.run to fix deadlocks, to kind of work around it. And so if you do see task.run that looks suspicious or code like this, just the downstream blocking. So just be aware of that. In this case, this is really, really bad, by the way, because we're parking a thread here and we're parking a thread there. And then we're using threads in here as well. So this is multiple kinds of bad. And in fact, there's an async overload for task.run. But this is just to illustrate a point that suddenly deadlocking code wrapped in task.run, it fixes it. But you're now running into the problem where you're throwing threads at the problem, and you're getting closer to that thread pool starvation issue. Here's a cute one that I won't spend too much time on, but in C#7, you had the ability to return things that weren't tasks from async methods, and that was really about supporting value task. But someone here's written a library where you can actually return a context-free task, and this language feature lets you implement your own async state machine, and that's what they've done. So in this implementation, it basically changes the way await behaves, so that before and after, it nulls the context out, and then it restores it. And so basically it's the same as if you use configure false everywhere. And if you look here, this looks exactly the same as that first one where we use configure false. Here's another good one. So this library is called VS Threading, and it's a really nice library. If you can get over the fact that it has Visual Studio in the namespace, this library is full of lots of really nice little gems, like things you'd expect to be out of the box for .NET. For example, async block and a whole bunch of other async primitives that you might just expect. And one of the interesting things it has is this joinable task factory. And this is a thing that lets you run code synchronously, like block on it. But it actually uses that blocking thread as a message pump to run the continuations. If we look at what that looks like here, it basically looks like we wrote the whole thing to be single threaded, which is quite interesting. So this actually is a bit more responsible than the other ways because we're only ever using one thread, never anymore. However, let's say we were using some third-party code in here and it used configure false. You can see that the implementation here used its own synchronization context. So inside that code, it's going to shake off that context, and then it's going to start using the thread pool. So it's not a silver bullet because, you know, on code you don't control, it's going to still run on multiple threads. You won't get any deadlocks with this, but it's still just not very responsible way of writing, blocking code. So the bottom line is don't block on async code. I've kind of danced around it a bit here, but if you want the full spiel, there's this blog post here from Stephen Tube who goes into the same sort of depth and covers it really well, and that's what we'll read if you get some time. And so that brings me on to some new stuff, because that was a lot of pitfalls and old stuff. So one of the cool things that came out with C#8 is something called async streams, or async enumerable. And it solves this problem, basically. So here we have an async method called getUsers. And this is a real API. This is the Zendesk API, users API. And when we call it, it gives us page results. So it gives us a JSON property called next URL, or next page even. And it just contains the URL of the next page. And so each time you call this, you get 10 users back, or however many it is. And then you just check to see whether the next page is null, and then keep going. But the problem we have is before async streams, we had no way of expressing this in our type system because one of the things you might do is you might do this. You might have a list. You might asynchronously await the results, populate the list, and keep doing that in a loop, and then return that whole list. But now we've lost the lazy nature of this paging API, and the whole point of this paging API was perhaps there's like 1 billion users, or how many users, and we can't fit it all into memory, or perhaps it's just that whatever the source is, perhaps it's just infinite in nature, and so we can't express it in types, and so we really want to use async enumerable here, and we want to use it because it has a familiar definition. It has this what we call this grammar, and this grammar is next star, which means 0, 1, or many next items, and then optionally error or completed. So it can finish with completed or an error, or it can never finish. It can just go on forever, returning us values. And this familiar definition is important because we then have a ubiquitous language on top of that that we know is link. So we can kind of reuse that link starter programming with anything that has this pattern. And so these things we may recognize. Async enumerable has this grammar. So does iObservable from RX. And now async enumerable. So we can start to reuse all those really good extension methods on top of this as just a side benefit. And if we look at the implementation for async enumerable, it's basically the same as IEnumerable, except the async iterator gives us a move next async, which is a value task, rather than just a Boolean. And so let's do some code. Nothing like live coding. So let me find my editor, and we're going to put it into presentation mode. And you have to tell me if this font's too small. And please put it in the comment and someone will let me know.
That's good.
Thank you, brilliant. So in this code here, at the moment I pulled in the AWS SDK client and the SQS client, that is. And if I've got the snippet here, you might do this sort of thing if you're using Azure Message Bus or RabbitMQ or some messaging queue system. And what you often want to do is have a little console application that you run in the cloud somewhere that just loops through and asynchronously pulls messages from a queue and then does something with those messages. So here, messages has a body. We'd deserialize that and we'd start to process it, and then we'd delete it from the queue. And this is a nice candidate for using async streams, because we could put our code in here to handle the message, but it would be really nice to kind of turn this inside out and have it. If we have it as an async stream of messages, then we can start to layer things on top of it, like buffering and throttling, filtering, all those things that we're familiar with Link. So we're going to do that here. So I'm using Rider here, by the way, which is amazing. I hope I can stay on that. So I'm going to extract a local function, and we're going to call it get messages async. And we're gonna, if I can type, yield return each message here. So previously in C#, you've been able to yield in iterator methods, and you've been able to await in async methods, but you've never been able to mix the two. And that's a bit odd, because basically both those features are the same compiler feature in terms of the way they've been implemented. They both end up with the same code and rods being used to generate you compiler generated code. They both turn into state machines. But in C#8, they've changed that now so that you can, by returning this async enumerable, we can now yield return and await inside of these async iterator methods. And so we're now going to get our messages here. And messages, we want to be able to consume that now. And there's a couple ways you can do that. I'm lazy, so Rider has this little helper where you can just have it write the code for you. But basically, it's just a regular for each, but with your wait keyword in front. And this will basically use that async move next. And so we'll asynchronously iterate over these messages as we'd expect them to. And then we can handle those messages as we want here, which is all well and good. But we can also use Link. And so if I go to my project file for a second, I brought in system.interactive.async, and this is from I pulled this in from NuGet, obviously, but it's on GitHub under .NET/reactive. So it's part of the reactive extensions family, and they have like 4 libraries, and I think it's like system.reactive for RX, and it's system.interactive.async for iasync enumerable. And we have things like, it brings in things like where and select. These previously weren't available to us out the box. And so in this dummy code here, I'm filtering for any attributes that have the a tenant. I'm selecting the body, which is a string, and then I'm going to do something with it. And I just want to show you that we have .select and .where, but we also have .select await. And this is because we actually need different methods for if we're going to be doing if we're passing an async delegate or not. So it's easy to, in the for each, let me just show you this, because this is an easy mistake to make. You might just think, oh, well, for each async, but this code won't actually run the way we expect it to. It's actually expecting a synchronous delegate like this. And so if we want to use async in here and want it to work as we expect, then we would use the await async. And And so all this code does, it selects the message here. Then we can do some handling here, and we could add things if we check out the various methods here. We can buffer and do all sorts of cool stuff that we might expect to be able to do from the extension methods we find in Rx, for example. So that's pretty cool. I'm going to show how cancellation works now. So if I do cancellation token, CT equals default. So we've just got a dummy cancellation token here, and we're going to pass it into get messages async. And I'm going to create that parameter up here. I always like to make these optional. And we're going to check to see if a cancellation has been requested. We're going to throw. And of course, we're also going to pass the cancellation token into any async methods that we call downstream. And so that method is now cancelable. And you can see the rider wants me here to pass the cancellation token. And so I'm going to do that. And so you can pass the cancellation token into these methods that kind of terminate these link statements. So I think, for example, count is another one. Count async, because that's a terminating thing. It's going to complete. It's not going to return a sequence anymore. We'd have to await it. You can then pass it a cancellation token. So we can do that, and we can do the same for, let's do messages dot for each. Have it write it for us. You can see that Ryder is suggesting something here. If we say, or in this case, Rosalind, pass the cancellation token. So to do it in the for each style, you use the extension method with cancellation, and you pass it the cancellation token. But at the moment, this doesn't actually do anything. This one does, and I'll get back to why there are two. But this cancellation token won't take effect. And that's because the compiler doesn't know that this cancellation token is anything special. We signify that it's special by adding an attribute to it. And I've got it as local function here, but I need to turn it into a regular method. And that's because right now, today, you can't use those attributes on local functions. But in master of Roslyn right now, you can. And so in the very next version of C# that comes out, likely with .NET 5, or I haven't actually tried in the preview. I think it'll work in the preview. We can actually use attributes on those local functions. If I come in here, you'll now see that Ryder wants to get us to do something, and it wants us to add this enumerator cancellation attribute, and that tells it that this is the cancellation token to use when we're doing that enumeration. And so now this does work, and that other link example works. And so you may be wondering why there are two places we can pass it here. And that's because we may not own this method here, or we may be passed this async enumerable into us from something else. And in that case, it's still very very valid for us to want to then express a cancellation token. And in fact, this method, because it's a state machine, unlike async methods, which kind of run immediately, this behaves more like an iterator method where nothing runs until you enumerate it. Until move next is called, we don't hit this first line here. And so we still have an opportunity to pass this cancellation token. The compiler generated code under the hood will still kind of combine it into this token here. So what happens in this case, just to be clear with the two tokens here, if we pass just one token, it's going to use that token in either place. If we pass two tokens, it's going to compare them. If they're the same, it's just going to pick one, doesn't matter. But if they're different, it's going to, in generated code for us, it's going to combine them into a linked token source, and it's going to use that. So it's just going to do the right thing for us, which is pretty nice. So that's cancellation tokens. And I'm just going to tidy this up for a second. I'm going to get rid of the cancellation token stuff because I want to show channels, and I don't want this getting in our way. So bear with me. Nothing like coding live. And so let's look at channels. Oh man, I usually code on a Mac, so this is tricky. So when we go to create a channel, I should probably start with what a channel is. So a channel is a really nice way of creating consumer producer patterns. So for example, you may pull something from a queue in this example, or you may be pulling something from somewhere, and then maybe you want a bunch of workers in memory to like process that thing as fast as possible. Maybe you're pulling them, you're pulling these big batches of items, and you want them to be worked on concurrently. That's a very typical example. There are lots of other patterns where maybe you pull from multiple sources and you fan them into just one worker or something. Anyway, and so if you've used a blocking collection in .NET, that might be familiar to you, because it's basically the same thing, but the asynchronous version of it. It's also like mailboxes if you've used another language that has the concept of mailboxes. Now, when we create a channel, we have to decide whether it's going to be bounded or unbounded, and odds are you're going to want a bounded channel, and that's just enforcing a capacity, and you're going to want that because odds are in production there's a logical limit to how many things you can keep in memory. Especially with message queues, we want to keep our back pressure in that message queue because that's what the queue is built for. Not, our application has no business having all those messages in memory. So here, when you construct it, you give it a capacity, or you can give it some options. We're going to give it a random capacity here of 10. And the options have a full mode. That lets you say whether to drop newest, oldest, or write when it's full, when it's at its capacity, or to wait, which is default, and it's quite a good default. It also has these flags for single reader, single writer, and this is for us to tell it, hey, don't worry, we're only going to write or read one at a time. We're not going to do it concurrently. And in this case, I'm going to say we are only going to write sequentially. So I say single writer true. Now, if I can type, and it appears I can't. If we look at channel, we've got just these two properties, a reader and a writer. And we're going to start off with this reader. We're going to pass the, oh God, it's all gone wrong. Bear with me while I get my editor back. I've basically thrown my editor to a totally different window. Okay, oh, it's back. Presentation mode, okay. Cool, we're back. Okay, so a common pattern is to pass a reader into your producer. So here we have a channel.reader, and then we're going to add that parameter. So if we look at our code here, so we're no longer going to be using async enumerable. In the return type, we're going to be returning a task. We're not going to yield return this anymore. So instead, we're going to do channel reader. Oh, did I say reader? Apologies, everybody. I meant writer. Disaster. Channel writer. Yeah, so you pass a writer into your producer. It's going to write into this channel. And so there's a few things on it. It has a complete method done with this channel. Also try complete, because if you're writing concurrently, then you don't know that you're the first person to complete it. And you don't want it to throw an exception. So we're just going to use complete in this case. In fact, we'll use it later. And it has write async, which is more commonly what you're going to want to use to write into this. But it also has these more high performance methods called try write and wait to write. And so what you might want to do is you might want to sort of optimistically write to it synchronously, and it will return true or false if it succeeded. If it succeeded to write, it will say true. And if you have an unbounded channel, then this is always going to succeed and it'll always return true. So you don't even need to look. But in the case where it's a bounded channel like this, if we were to write to it, or try write, I should say, and it returns false, then we need to wait because it's at its capacity. So we'd then use this, we then await the wait to write, and then we'd go in again. We'd probably loop through and try writing synchronously, if that makes sense. But here we're just going to write the message out into that channel. And of course, we need to await that. And we're going to be good, and we're going to wrap this whole thing in a try catch. And we are going to channel writer we're going to complete passing that exception in. And so up here, we've passed in our writer. And unfortunately, if we await this thing, which writer wants us to do right now, it's never going to complete. So what I'm going to do instead is, apparently hit the wrong button. But what we're going to do instead is not await it. That's the thing I said I wouldn't do. We're going to just discard that task. Now, it's actually good practice not to discard tasks. You probably just want to put that in a field somewhere. And even if you don't ever look at it, it's good just to have it for debugging purposes. But in this case, I'm just going to cheekily discard it. So we've got our writer, but now we want to be able to read from it. So if we look at channel.reader, it's got some familiar methods here as well, right? It's got a completion property that corresponds to the completion on the writer. So we can await this to see when it completes. It's got a read async if we just want to pull out one value, just like we had write async. And equally, it has try read again. It will try to read synchronously. And if that collection or that channel is empty, it will then asynchronously wait. In this case, it won't wait because it's try read. It will just return false. And then we'd use wait to read. So we might want to use that in a high performance scenario, but it also has this read all async. So I'm going to call that. And if we look at it, if we look at the implementation here, oh, come on, please work. We can see it does exactly what I just said, which is it awaits to waits to read, and then it will try in a tight loop to read out opportunistically, sort of optimistically, synchronously read out all the items until it's empty, and then it will wait again. And that gives us an async enumerable. So now we're back on that previous code I had before, where we can start to consume that with that link method, link syntax, for example. And now we probably want to be able to consume this concurrently to be able to process as many messages as we can. So if we get rid of that, we might do something like this, where we spin up 10 tasks, and we have that very same code in here, where each of them gets a async enumerable, and then we can start to sort of party on that from how many threads you want, and it's completely thread safe, and we can start to do all that fun stuff. So this is a really nice pattern. And at the end here, I'll just await task.when all, and we can wait for those workers to finish. And they'll only finish once the channel is completed. So we could have done await.task. If I can do no await reader, no channel reader dot completed. We could do that. But that's redundant because these workers are only going to complete once that channel reader is completed. And so it's really kind of nice, and it's really kind of simple. And there's lots of places in .NET where we want to do this, and we want these asynchronous producer-consumer patterns. So I'm going to switch back to my slides. And that's me. So I'll jump over to I'll stop sharing. I'll jump over to the chat now and see how we're doing questions wise.
Nobody asked anything.
Nobody asked any questions.
I'm going to unmute everybody's mic. You can, if you want to ask a question now, then by all means do.
Thanks, Kev. Yeah, any questions? Go for it. A stunned silence.
I don't know enough about async, so that really helped. And it really makes me think that maybe I should spend some of this time of social isolation going and looking how async works properly, because I generally use it because I don't want to block a thread and I just put whatever comes naturally in there and leave it with it. But I'm guessing, just like you just put, that there's going to be a time and a place for all of these different options. And just like Ian Powell mentioned, that channels looks awesome as far as queue reading.
Yeah. And I want to stress how simple that is. It sounds, when you hear it, you're like, oh, channels, that's a, that's a whole concept. It's like, when you look at it, it's, you just a couple of methods to really start, using it. It's really simple. So that's a great takeaway as well. Yeah.
Everyone's so quiet. It sounded like someone was going to ask a question or say something at least then. Okay, well, if you do think of any questions, then you can carry on typing in the chat window there. But we'll switch over now, and thankfully we don't have to do laptop switching or anything like that, but screen sharing switching can be just as fraught with danger. But again, I'll mute everybody and just feel free to use the chat window. Let's do this and then unmute Simon, otherwise that's going to be bad. Also, again, I'll unmute Stuart so that he can do what he likes. And then Simon, wherever you've disappeared to, you can share your screen.
Yeah, still here. Sorry, just trying to get it sorted.
No worries. Told you, this is just as hard virtually as it is in real life. But at least you won't have the problem I had over at DevOps Knots when I did my talk, where the projector decided nothing was going to project on it for about 10 minutes, including having to turn the bloody thing on off and back on again, which was annoying.
Right. There we go.
Oh, and I do love that. It's just awesome. You should explain to people where that came from.
Well, the artwork.
Yeah.
I was a chap I ran into on Facebook did that for me. He's actually just, if you want to go to his Facebook thing, he's just released a book of his art for anyone interested.
Oh.
He does, there we go, sorry. One sec. There, sorry, just correcting my microphone. Yeah, he does all this sort of Spectrum-y style artwork. I ran into him on a Fighting Fantasy game book board where he was doing Spectrum-y style versions of the artwork from the covers of the books. It was well cool. So, thought it'd be fun to have a go. His link to his work's down the bottom there. Andy Green is his name.
In the chat now too.
Sorry?
I've just put that link in the chat so people can click on it.
Ah, cool stuff. Right. Oh, okay. Are we good to go?
Yep, do it.
Let's do this thing. Right. A little bit about me for anyone that doesn't know. Been doing software dev for about 15 years. This is my second time here, so I probably won't dwell on an awful lot of this quite in that amount of detail, but worked in a lot of places. Now currently one of them dangerous contractors that are supposed to keep 10 meters away from normal people at all times. So I present to you the great conflict of our time. We have two, allegedly one man, one teenager, but let's face it, he's fooling no one. But two men here. The one is straight-laced, ordinary, sensible, and the other is the doesn't put so much effort in. And of these two, which of them got to travel around in a flying time machine, see the future, and almost sleep with his own mum? Well, okay, don't be trying that last one at home, but we can at least argue that it's not dull. So the point is that I want to try and find ways to do all the same work that we do now, but with an awful lot less effort. I don't like writing too much code. I get bored easily if I have to keep writing the same chunks of boilerplate over and over again. Life's too short, so I like to treat each line of code like it's expensive. So these are the sort of standard parts-ish of a project. And of these, I want to concentrate on those where I feel that developers can make the most saving in terms of our efforts. And the parts of these that we can't do anything much about, those are gathering requirements. That's generally for your business analysts. Designing a solution, sometimes can be, can be not, don't know, depends. But coding for sure, yeah, that's the initial coding effort. Testing is your testers, and you've got your enhancements too. That'd be us as well. But of these, enhancements is by far and away the place that any code spends the vast majority of its time. I would normally ask for shows of hands at this point to give an idea of the age of everybody's code bases they work on, but I would be pretty astonished if there weren't a load of people listening right now who don't have a code base upwards of 15 years old. I certainly have been working on those recently. And this is probably where nearly anything spends the majority of its time. So the place where you can make the most saving is in enhancements, in the, there we go. And these are the things I think cause the most delays when we're working on enhancements. Now, unclear requirements, well, that's again down to your business analysts. Project management issues, that's between you and whichever PM you believe in. But the legacy code base, that for sure is something that we can do something about. That is one of the biggest problems for me as a developer. And what's the problem? What does the code actually mean? I cannot, we've got just seconds. Can I open the chat? Oh, sorry, yeah, I just put in the chat up so I can look at that as well. Oh yeah, Pete says he's got code from 1999 that he's still, yeah, totally. Gosh, yes. I've worked in systems that probably older even than that. But anyway, so the problem I get is that someone comes in and they and they say, you know, we just want you to do this little change. Just a little change. Go on, go away, add this one little thing in here. We've got a rule of 5 things. We want to make it 6 things. Dead easy. And the problem I get is where do I make my change? There's problem 1. And even then, when I've worked out where to make my change, and that's generally harder than anyone would ever expect, because you'll find, yeah, sure, there's 5 rules, but 2 of them are split between several database procedures. 1 of them is in a sub-library. 1 of them is split in 4 different places and only appears cumulatively when you run the code. It's hard stuff. And even then, when you look at each individual function, it'll often have names like go do stuff. And then when you look at this function, it does about 5 things. This is the hard stuff that we have to put up with at the moment. And there's no real need for us to have to put up with this rubbish. And one of my regular bugbears is code that's not written in a way that's nice, concise, easy to look at. Yeah, and someone's just pointed out, if it's only 1 line of code, but where in the 100,000 lines of code you add it, absolutely. Totally agree with that one. And this is the stuff that the business never really seem to quite appreciate. They're just thinking you developers are taking your time, but no, it really is that hard. Oh, come on, keyboard. We can do it. There we go. Right. And these are, vaguely as I see it, the elements of a function. We've got our parameters. That's the stuff coming in. The return value, that's the stuff going out. And in between, we've got these 2 guys. And by which I mean business logic is, if you asked the business, what does this thing do? That's what they'd say. The business logic is the what. That's the what this thing actually does. That's the what of the function. And the code structure is the boilerplate that we have to write in order to make it work. That's the how this function works. That's the stuff to deal with the looping, the stuff to do with building structures, the stuff to do with null checks, with validation, the sort of standard stuff that we write time after time after time. That's the code structure. And I would argue that an awful lot of the confusion that comes in with the functions that we work in is where these 2 things have become totally bound together to the point that they are each mutually obfuscating the other. there is a concept in audio engineering called the signal to noise ratio. And the signal is the thing you're actually trying to listen to. That's the voice, that's the music, that's it's the whatever, the thing that actually you want to hear. The noise is everything else that comes with it that you're trying to minimize. In a cassette, it's the hiss in the background. In a record, it's the rumble. In a VHS, it's that sort of funky thing it does with the colors. In a Justin Bieber album, it's the album. You get the idea. So what I would argue is that we want to even apply this concept to our coding. We want to minimize noise. And the signal is the business logic. This we want to enhance to make this the most readable, most prominent part of any function that we write. So what is coming is several different sections giving some of the ideas that I've come up with over the years for performing this exact thing. So part one, noise simply at the line level. So here's a function. What does it do? You have about 5 seconds. And of course, it'll take you a lot longer than that to understand what on earth it's doing, because there's an awful lot of code there. There's loads of it. And most of it is boilerplate. Most of it is noise. What this is actually doing is going into the settings of an app config file. It's pulling out the values. It's doing things like null checks and validation checks. And then if they don't exist, we're applying default values. It's doing a lot of stuff, but most of that we don't really care about. When it comes to making enhancements, all we really care about is what you're getting, what's the default. That's all we want. So the rest of this is just noise. So a couple of extension methods. And if there's anybody that doesn't understand extension methods, peep up now, because it's going to be a tough night for you otherwise. So these ones are attaching to strings, and they're saying, provide me also a default value. The one of them is going to an integer, and the other's string. And in each case, it's doing all of the check against null white space, etc. The int one there is trying to do the parse. If it doesn't work, then we go to default, and whatever default is being passed. I don't have to use my mouse, can't I? Wait, this is fun. Okay, so here we're providing a default value as an integer. So by providing a default value as an integer, we know that this is meant to be an int. So we do our try parse, we try to turn it into an int. If the thing is absent, or if this is not an int, then we get default value. Otherwise, we get our parse value. Same with the string here, it's just a little bit simpler. But all of that means that we can reduce all of that code noise down to just this. Strictly speaking, this is just one line of code. It's a really, really long line of code, I will grant you this, and it's almost unreadable without some new lines, but it is still one line of code. And it's an awful lot easier to read. Each one of these kind of lines is doing something crucial, something meaningful, and something that's actually worth reading. We know the value going out, we know the value from the app, and we know what the default is in one line. If we wanted to enhance this thing, we'd simply add one extra line in here, or if we needed to modify this, we know precisely where to modify. Easy peasy. The meaning of our code isn't lost in all of that boilerplate. And at this point, I'm going to pause and talk briefly about extension methods, because they get a little bit of a bad rep. I know a lot of people moan about them, and there are reasons for that, and they're often used poorly, but if used well, they can be very powerful, which is why I'm going to go into my commandments of extension method, which I would argue if you follow, you'll actually get good use out of them, and you won't run into the problems that a lot of people complain about. And of course, when I say commandments, as always, it depends entirely on what you're trying to do. So use some common sense, use a bit of creativity. So the first, don't include business logic. Never, never, never do this. The point of an extension method is kind of like that snarf action figure that you've been holding in a cupboard since the 1980s that you don't want to get rid of, but you also don't want anyone to really know about either. So you're stuffing it in a box where no one can see it, but where it's safe. And that to me is an extension method. The whole point is we're taking this little block of code and we're hiding it in a box where no one really ever needs to look at it. Business logic, on the other hand, needs to be out front where everyone can see it, written in big writing, so it's obvious. We want business logic to be easy to find and clear to anyone that ever needs to access it. So the moment you put business logic into an extension method, you're going down the dark path. Keep them compact. I'd argue that, in fact, if you go over one line, you've probably gone too far. I keep them small. I keep them extremely tightly focused and as compact as I can. Keep them generic. Sometimes I can't. Sometimes there is a specific reason. But generally speaking, I would, wherever possible, create them using a T to make them completely generic so they apply to everything. I generally would never apply them to my own classes that exist, because that's, again, starting to touch on business logic, and you probably ought to be creating another class for that. But if it's any sort of basic C# structure like a string or an int, then sure, that's probably generic enough. Keep them portable. I work to the principle that they should be something that I could just drop into any project anywhere in the entire world that is C#. If you start to put in stuff that's project specific to your project, again, you're probably going down the wrong path. I have a little text file that I keep about, which has got all of my standardy extension methods. I often refer to them as hacks, which is kind of what they're there for. And I'll drop them into any old project I feel like needs them. And use them to reduce boring, repetitive code, to try and get rid of code noise, code boilerplate. That's what they're for me. That's where they are useful. And actually make them useful. I was told a story not long ago about a business that created an extension method called isTrue, which returned true. And that to me seems totally pointless. So try to keep away from that sort of thing. But provided they're useful, provided they're generic, provided you could just drop them anywhere, provided they're not project specific, I think they're totally useful, valid features of C#. So we'll start with, this is another example of the sort of extension method I might write. This is a completely generic parser. So this is taking in a string as this. It's attaching to a string. It's assuming that that string has come straight out of a CSV file, and it's splitting first based on the line, which will often be a new line, might be something else, but generally it's a new line. And then do another select, splitting out each line by something else, which will often be commas or whatever. And then bang, we've got ourselves an array of arrays. And that's an awful lot of boilerplate code I never need to write again. So if I've got a project that's full of parsing in various places from CSVs of various formats, we've got ourselves something that we can just throw in and use all over the place and cut ourselves out a whole load of boilerplate code we don't need to write anymore. A couple other examples. Again, these are just examples. A bit of creativity, and you could probably come up with dozens of these things. I have a little project on GitHub that I run, which is full of all sorts of stuff I've thought of over the years. So a check against null and empty. That sort of thing could be useful in some places, depending. So it depends on what you're trying to do. And usually, again, rule of thumb, the moment that I do a little bit of boilerplate like that twice in my code, that's the time to extension method it, because I don't like to do the same thing twice. Dictionaries are super powerful for reducing code noise. I love dictionaries. I'll get into dictionaries a little bit more in a bit. Dictionaries are one of my favorite features of C#. But sometimes the syntax for actually creating them I find a little bit bulky. In this case, I've created myself an array of key value pairs, And I've got to do this slightly awkward dictionary-ish thing down here where you specify 2 different lambdas. I don't really like that. That's slightly slightly more work than I'm really interested in because I'm frankly very lazy. Oops, come on. There we go. So we could stick in a couple of extension methods for just automatically converting all sorts of things into dictionaries. There we go. I'm converting here, and in this case, I'm converting an IEnumerable of tuples into a dictionary using this. So, that's an awful lot of stuff I just don't need to think about anymore. This is the simple stuff at the moment. We'll be getting on to some more complicated stuff later. Another thing that I do sometimes, because I may have reports to write, is to count dictionary, which is take my enumerable of stuff here, group it by itself. I'm assuming that this is going to be something like an enum maybe, or something like that. You can write more complicated versions of this. And then I'm dictionarying it with the key here and the count here. So what you get out is a summary of all the values with a count next to them in a dictionary, which you can use for all sorts of things. So those are funny little mini single line hacks, but then some hacks to remove chunks of code structure from. So something I have often had to do when I was working for an American company, which I did for about 4 years, and being British, I like to talk about the weather, was to try and work out the differences between Fahrenheit and Celsius, because the folks in the US would tell me that it was 100 degrees outside, and to me that sounds like it's hot enough to boil water. What they mean is I think that's about 35 degrees, something like that. I don't really know. But the process for converting between centigrade and Fahrenheit is something like multiply by 9, divide by 5, add 32, and I'll do a little bit of something here where I convert it into a nice string. But I've got an awful lot of stuff going on here that I'm far too lazy to do. I've got to create these one-use variables, which are only going to exist for a moment, and I'm going to chuck them away. There's all this var equals, there's this return here, and these lines, all of which I can actually remove by the simple addition of the greatest little extension method you never knew that you missed. That's this one. It's called map. I've heard it called other things too, but map is good for me. And what map is doing is it's attaching to everything. This is a generic, so it attaches to everything in the whole of C#. And then after that, it's taking, as its single parameter, a func. Again, if we're not good with func delegates, then scream out now because it's going to be tough for you otherwise. But it's going to take a func delegate, which converts whatever it was into whatever you want next. And that says here is an if. And then simply we pass this, whatever this is, into the func and return. So it means I can reduce that entire function down into this. And I've been able to delete a whole load of bits of code. I don't have to store any little temporary throwaway variables I don't really care about. And all that those variables would be doing is taking up headspace trying to work out what any of them are doing. And I don't care. I know that this map is something I can ignore. I know the arrows are something I can ignore. And I know now that this is a series of steps. Each one, in effect, is doing an operation, taking the result of this, passing it into the next. Do this, pass it to the next, like a relay race. If anyone is interested, the technical name for this sort of structure is a monad. I'm not planning on dwelling on that further now. Ooh, someone's question, divide by 5. You, sir, have spotted the deliberate error. You win. Well done. Everybody cheer. That definitely wasn't due to my stupidity. Right. So, right. Yeah, so this is an awful lot easier to read, though. And it brings us also some some additional benefits. Where the first is it forces whoever maintains this thing not to start putting extra stuff into this function. And that's important because the moment that a function starts to do more things than it's designed to do is the moment that it starts to get harder to maintain. Because like the proverbial broken windows, once you've broken one, it just carries on getting more broke. So we want to enforce fairly strict rules on what can and can't go in the function. Another is, and this is something that not a lot of people consider, if you've got a gigantic function upwards of 1,000 lines long, and I have worked in those fairly regularly, and you define something way at the top, it's still in scope at the bottom. And so by using this method, any of these x's are only in scope for the duration of the execution of this function. So this x here, once this is completed, then, and we've moved on to this function, this x is disposed, or at least subject to garbage disposal. So we're throwing a bone to the garbage collector, and we're not holding on to any resources for a single second longer than we need. So all sorts of benefits, and all that we need is this little map thing here, which an awful lot of languages have got equivalents of, but not in C# at the moment. Something that I've had complained about when I talk about map is, well, what about logging? What about debugging? Hey, we have an answer. I don't know why this thing often gets called T. I've heard it called all sorts of things. I've heard it called tap as well. I've heard it for a few things, but the basic principle is the same. We have ourselves, again, an extension which attaches to everything. And this time we're after an action being rather like a delegate, func delegate, except it has no return type. It just acts. Excuse me. So I'll feed this into the action and then return whatever this was back again. So the result of that is action is carried out, but nothing is actually changed in the chain. So if we do something like this, this is our same function again, but right in the middle here, I've stuck in a call to the proverbial logger. You could put a console.write line in there. You could put whatever, a call to log4net, whatever. But the point is that in the middle of this chain, you don't have to stop in order to do login. You can just make it part of the chain. And then by using this T, you're making a very specific decision that whatever goes on in here does not affect the flow of the program. So here's another problem that we run into all the time and have to write a lot of boilerplate to solve. So we've got ourselves a prepend string method here, which prepends the word hello. Also, prepend is a word I nearly never get to use, so I'm going to use it once or twice more. And we're doing two calls to a proverbial, I don't know, maybe it's a database operation. Maybe it's a check against an XML file. It doesn't really matter. But the point is there is a data store of some kind. And using these IDs, I'm going to go away and fetch a person, possibly Satan, I'm not sure. But whatever. And then I'm going to prepend to each of these the hello to their name. Now, the problem is, you see here in my description, 666 does exist in this example. So this will go away, get a name, and that will be fine. But this one returns null because it doesn't exist. So normally, okay, this is where I'd normally ask the audience, feel free to scream it loud at your screen if you wish. But what would normally happen here when I call .name when this is null? And the answer is an explosion. You'll get a null exception error. This is not good. Our defense against this is often to write a whole load of boilerplate code like this, where we're checking against null. We've now polluted the clarity of the function with a whole load of boilerplate, which is, yeah, well done, Ian Powell. Object not set to instance of object. That's exactly the one. So, yeah, so we've muddied what this is actually doing by having to add in all of this defensive coding. And I don't like that sort of thing. I liked it when the function was easier to read with fewer lines. So this is why we can throw in a good old extension method to handle that stuff for us. So where this is an extension attaching to whatever this is, we've again got a func which converts from the old type to the new. So it's not unlike our map, but now we're doing this additional line here. Now this looks a little scary, but all it is a generic version of a null check. So this is because a generic could be literally anything, and not everything defaults to null. Most things do, some things don't. So your integers don't. Integer defaults to 0, bit defaults to 0, Boolean defaults to false. You all know the deal. So I am saying in a generic way, we'll check this. If this is not null, then let's actually run the function. If this is null, then we'll just return default, whatever that happens to be. And it means that we can convert it into something like this, which is a lot shorter. And not only do we still have the null check, but now we're doing it with a description of what we're doing. Instead of having this sort of boilerplate that we're all kind of used to, and most of us who've been around for a while probably can work out what it does, instead I've got a literal description of what the defensive code is in its place. So this now here inside is an arrow function, which is going to do the biz. But in the case of person 2 now, it's going to do a null check and then refuse to execute this function and go about its business. Now, hello 2 is still going to be default. And of course, we could do all sorts of things to prevent that from being an actual null and maybe convert that to an empty string. There's plenty we could do, but that's pretty good at the moment. So moving back onto dictionaries, which are one of my favorite things. So here we have a dictionary containing references to the first 5 actors who played Doctor Who in Doctor Who, the best TV series in the entire world. No arguments on that. Not allowed. I don't allow it. And I'm doing a hypothetical get doctor function, which is going to take an int, and then whatever doctor that is, it will come back and tell you the actor who played it. So this one is fine. This get doctor 1 is William Hartnell, the boss. But this one is asking for the 100th doctor. There ain't yet a 100th doctor. So what is this gonna do? And this is one of the most annoying things, to be honest, for me in the whole of C#, because I like dictionaries and I love how lovely and concise this structure is. But if you try and ask for something that's not in the dictionary, you get an exception and your app dies. And this is honestly a little bit silly, because that forces you, whenever you want to use a dictionary, which has this lovely sleek syntax, to surround it with a try-catch block at the very least, or to do checks against the contents of the dictionary. You're having to add a load of noise in just to be able to do something that would otherwise look rather lovely and elegant. So this is the solution I've come up with. And to me, these extension methods have suddenly made dictionaries an awful lot more powerful and desirable. I'm converting them into a lookup function. So this is a function that takes a dictionary and a default value, or possibly in this case, we're just assuming you want the default of whatever it is. And we're doing a check against whether the dictionary contains the key. If it does, we'll return it. Otherwise, we'll return the default value. So in that single little bit of code here, we've just converted our dictionary into something we can use more effectively. So now we can do this. So it's the same dictionary as before with the same nice syntax. And I'm calling to lookup with default, and I'm saying don't know now is my default. So that now means that this is not a dictionary anymore. Well, it is still a dictionary. This dictionary still exists. But behind this, but this has now been wrapped into a function. And the function is kind of sitting there as a filter between you and the dictionary. And it's acting as a gatekeeper to stop you from trying to do something that would cause an explosion. So if you put in the 100 here, it'll check in the lookup there that there is 100, there is not, so it will return the default, which is the don't know. So the only difference is that now you need to use curly brackets instead of square, but other than that, it functions exactly the same way. And so long as this function is in scope, so is the dictionary. And we can actually go a step or two further. So let's say that for whatever inexplicable reason, I wanted to create an array which contained details of the first, third, and fifth Doctor in an array for some reason. Then I've got to do this slightly awkward lookup of get Doctor, get, and so on. And there might be a whole load of these. And that's a bit tedious. But did you know that you could use indexes on everything? Well, probably you did. That's pretty good. Okay, so an indexer is just a function here. You stick this inside your class, and that means that you can use the index square brackets to reference whatever this is and do the thing, get the Doctor. That's good. but we can still go a step further than that. Because did you know that an indexer can take params? Now, I didn't until fairly recently, and I found this a little mind-blowing. So if you have params inside the indexer, that means that you can take in effect, an array of the stuff you want, and then use good old link to select it into the actual data swapped for the indices if you prefer. So that means that when I call this thing, that function call that you saw a bit ago, converting the 3 calls to the get doctor function into an array, is now just this tiny little bit of code right here. And that's all it is. This will actually constitute 3 calls to that lookup function. But all of that boilerplate is done away with. And we've reduced this to the very barest minimum that we need to bother writing. So moving on to another bugbear of mine, people who copy and paste functions. So this again is a big block of fairly wordy code with an awful lot of stuff going on and an awful lot of structure. Now, what this is actually doing is going away to a hypothetical data store, check whether there's any data come back. If there is, we'll generate a report. If there's not, we'll just send a message to say there was nothing. And we're also doing some error checking. So good, fine, nothing wrong with it per se. Now, because we're good people, we'll put some unit testing in. So we'll unit test the happy path, the fact that there was some data back. Good. We'll unit test that no data came back and whether it got the right message. Still good. We'll unit test that there was an error and whether it's handled correctly. That's great. So we've got pretty much 100% unit test coverage now of this thing, and that's fantastic. But then, suddenly, you look down at your coffee and you notice that, like a scene at a Jurassic Park, there is a rippling, slowly pulsing in the coffee. And you look up and you notice it's your boss hovering over you like the spectre of death. And what they have asked for you to do is now to do the exact same thing again. And this time it's for property 2 rather than property 1. And what I know an awful lot of people do is, are we going to? No, go on. There we go. There we go. What an awful lot of people tend to do is just copy and paste. Now, it's tempting to think that the jobs are good now. We've just copied and pasted. We've got the exact same code again. It's doing the exact same thing again. The business need is satisfied, and that's terrific. But the problem I have is, what's the unit test coverage of this function right here? It was copied from a function that had 100% unit test coverage, but the actual coverage level of this one is 0. There's not a single unit test associated with it. We've doubled the amount of code that we've written, but we've halved the amount of unit test coverage. We've effectively doubled the amount of risk to the system with the code that we've introduced. And that's not good. In addition, this sort of approach has a problem if you continue scaling it up. I have worked on systems with fairly complicated rules that had to be duplicated every year with some small changes, a process that carried on for about 15 years. And then when we looked back about 7 years ago, we noticed that someone had made several fairly silly mistakes, and everyone who'd worked on that system since then had simply duplicated all of those errors going along. It's a very inefficient way of working. And although it appears on the surface to save you a lot of time, really it doesn't. And what if we discover a whole new method of doing some of this that's more efficient as a lookup to the database? We've got to go and change the whole lot. So, best technique I can think of is, I don't know what a better word is for it, but I'm calling them donut functions because it gets me to look at a picture of Homer Simpson here. There we go. So, convert my prop thing to a private, stick in a func. Now a func is going to convert whatever the data object coming in is to an integer, which is my my thing I've selected, or that could be a t. There's all sorts of ways you could do that. And then actually create my my public functions referencing the private, which has got a func, which the func fills in the only bit that's different between the two functions, and that is which property is being selected. It's an integer in both of these cases, so fine, it's just an int, but we could take this a load more complicated if we wanted to this to adjust to all sorts of other different data types, but for the time being we don't. So we've now okay, no, there. So this is our hole in our donut here. This is the func that we've passed in as a parameter, and that's the only difference between the two. And so that means that for the two functions that are actually public, that is literally the only thing that we write, the only bit that's different. All the rest of this is just dealt with for us now. We never need to worry about it again necessarily. And if we do discover some more efficient way of doing any of this stuff, then every single call to this will benefit all at the same time. Those are our functions. That's all they are now. And this is telling me something. This is actually telling me what the structure of this thing is. And that is being that these are the only things different. Another donut function I've had to write in the past when I work an awful lot with EF. I'm not the greatest fan of EF, but there is a lot of boilerplate you need to write if you want to work with it effectively. You need to use your using. You need to potentially call a to array at the end of your query. Otherwise, strangeness can happen. You need to do your try catch. Now, don't actually do this in production. I'm just doing it for the sake of example. Oh, Pete says he likes EF. Ooh, I'm not a big fan. Too clunky. It's like trying to ask a dinosaur to do ballet. Right. But anyway, you can... Alternatives? Dapper. Dapper is cool. Dapper is lightweight, and Dapper you can write your query very optimized. I like Dapper. Use Dapper. Dapper is good. EF is, I suppose it gives you the benefit of you've got this sort of object-orientated way to work with the database, but it's very, very hungry for data. It has this tendency, unless you rein it in, to suck out loads more information from the database than you actually need. And if you don't do it just right, it has such a tendency towards memory leaks. Someone just mentioned EF Core there. I don't know. Haven't used EF Core. I've just used EF Classic. So, but all of this boilerplate, though, is part of the optimal way of interacting with an EF data store. And rather than doing all of that every single time in every repository I ever work in, why not just write this thing once as a queryable to queryable? That means that I can just say, this is my query here, and I can pop the data into it, allow the person on the outside to write the query for me, and I will just take whatever they queried, and then I'll to array it here. Do also make sure to array. Another bug, bear in mind, don't be using toList. Only terrible people use toList. And there we go. All of that dealt with for us. So a few more slightly creative ways to use func, because func is... Kevin Smith says no one wants to write SQL. Nothing wrong with writing SQL. Writing SQL is fine. Right. Creative ways to use funcs, because funcs are super powerful in C#. So a little bit of function here to validate a username. I am saying that it must not be null or white space. I'm saying its length must be less than 2. Sorry, greater than 2. Its length must be less than 20. It must not be Justin Bieber, because it must not. And if any of these conditions occur, then we're going to return false from this function. Otherwise, we're going to return true if none of them hit. So, yes, Pete Gallagher says it must never be Justin Bieber. It must not. It's just, there's some sort of rule of the universe. And this is a lot of boilerplate, though. We've got this repeated if the thing return false with our return true at the end. That's a lot of wordiness. Plus, if you're leaving this open like this with the ifs that are, I have seen how things go. It's just ifs at the moment, but then someone will start putting brackets here, and then there'll be a sub-if and a sub-if, and you can end up with these gigantic, unwieldy structures that look like more like family trees than code, and that is entirely is absolutely against any sort of ability to keep the thing maintainable. So this is a little extension method called validate, and all we're doing is taking this, and I'm asking for a params, because params will save us a lot of boilerplate, and we're asking for a list of funcs that turn t, whatever t is, into a bool. I'm calling them predicates because that's kind of the technical term, and I'm calling that with an all. Now all is just link, and what all does is go through these predicates, go through them one at a time, stuff this, whatever this is, into each one. And because this is an all, every single one has to return true. Otherwise, the whole thing returns false early. So it means that I can convert that entire function into something like this. This is technically entirely identical to the previous function, only now it's an awful lot more compact. I've got to kind of had to flip the logic, because now we're saying that these are the things that have to be true. There's ways around that if you wanted to go back to the way we were, but I'm just saying not null or white space, greater than 2, less than 20, does not contain Justin Bieber. And we've compressed all of that down an awful lot shorter than we had it before. And you're also preventing anyone from making this function any more convoluted than it needs to be. Another thing that we could use is apply ops. I've used this in the past. This is an aggregate using functions, and I'm hoping we're all happy with aggregate, which is just a way of turning a whole array of stuff into a single value at the end using an initial value and so on. So all I'm doing is aggregating based on running each of these functions in turn, and whatever comes out of each function, passing in the previous total, becomes the new total. So that means that we can convert that whole 2 Fahrenheit thing into just something like this, which can be applied to anything. Another bit of code structure we could write is something to get rid of stuff like this. This is from the sort of thing that you'll see in factory functions, where we've got a whole load of types potentially that we might be inheriting from, and we've got to determine how to create each one. And you could just stuff all that stuff into a dictionary. And now the dictionary is going to handle all the code structure of deciding where to direct the code, because you can actually have nearly anything as the key to a dictionary. And you could even, as in this example, have a type as the key, and then a func afterwards as the thing that's returned out. So you pass in the type and you get back a function which will tell you how to actually create that thing. So again, we're even getting rid of code down on the level of the routing of the code. So being lazy, moving on to being lazy with enumerables. Now, the code itself in C# can be lazy. Enumerables are inherently lazy. So an enumerable is not actually data. And an enumerable is just a pointer to where the data is. And until you actually go and get the data from an enumerable, it hasn't got it yet. It's still sitting wherever it was. So imagine it this way. It's just a pointer to this is a really dumb array of strings. And in the real world, this is probably, it wouldn't really matter if this was an enumerable or not, but I'm keeping things simple for the time being. And the enumerable is just sitting here with a feature called current, which is just pointing over here to say that's where it is. But what if our enumerable was pointing at an array of functions, each of which may potentially have a slightly expensive operation to perform? It might be something that assembles a complex object out of the database. It might be something using EF, whatever. But the point is that each iteration through the enumerable might potentially be expensive. And if we can hold back on doing that for as long as possible, that's a good thing. Because what if the code later on actually precludes using the contents of the enumerable? If we leave it in its lazy state, then we haven't actually enumerated and we've gotten ourselves a performance benefit. And in fact, if you want to modify an enumerable, if you want to modify a value out of it, you've actually got to do something like this. So here's our initial array. And what you would have to do is to array it. Don't to list it, please, children, don't. Grab ourselves our new value. And in this copy, in effect, of the array, we have to pop the new value, and then we'll probably return that out of our function with an enumerable pointing at it. So where we had one array, we've now got two, when all we want to do is amend a value. So what if we didn't actually have to enumerate the array in order to make a modification? And this is the answer I've come up with. I've called it adjust. And what adjust is doing is saying, take this being an enumerable, and we'll have a function which will tell us what the criteria are for doing a replacement. Either I will give it t being whatever the current object is, int being the current position within the array, and bool being that's the return value, should it be replaced or not. And here I also request the replacement. So then I'll do a select based on that. Now there's an overload for select that surprisingly few people know about, and that's where you pass in an arrow function with two parameters, this being the object and the position within the array. So 0 on the first iteration, 1, then 2, and so on and so forth. And then I'll call should replace, pass in object pos, and then based on that, I'll decide to return the replacement or the object. So here is a slightly silly example. So again, I've got my ABCD array, and the other two calls here are doing the exact same thing again. I'm saying here, if the position within the array is 2, that's 0, 1, 2. If it's this one, replace it with a Z. With this one, I'm actually operating on the properties of the object. That being, is it a C? If so, replace it with a Z. So they're doing the same thing. But my point is that after all 3 lines of code have executed, in fact, the array has not been modified. No operation has been carried out. These functions haven't executed yet. The only time that you would actually execute these functions is when you either iterate through this array or when you call to array. And it's only at that point. And if you never use this array, these functions will never implement. Whereas using other methods, you would actually have to force a to array, do some operations, create a new array, and so forth. So we're allowing the compiler to decide when to actually carry out this operation. And it will usually wait until the latest possible moment to be as lazy as it can. If you want a visual example, incidentally, I know I can't draw. If you want a visual example of what this looks like, it's like filters. So we've got our enumerator. The enumerator is kind of the engine that runs under the surface of an enumerable. And it's trying to go to this array. And actually what's happening is we're passing through several levels of filter. And each one of these filters is a call to adjust. And each one has got a condition under which a replacement should happen and a replacement value. And so for each iteration of this array, you're checking each filter in turn to decide whether you should replace or not before you're returning back an actual value. So another circumstance where you might want to actually force a to array, and now this actually is an array, but let's try and imagine, is if you wanted to check 2 consecutive values. So this is a function which is going to blast through the array to see if any 2 items within this are consecutive. Now, spoiler, they are 15 and 16. But normally you would have to force a to array here in order to be able to use the indexer to reference I and I plus 1 or something of that sort. But you don't strictly have to do that. So I'm creating an extension of any right now. So this is still taking this being the enumerable and func tt. So t being one item if from this array, t being another item from it. So those are going to be consecutive items out of the array. and then a bool to see are those whatever it is you wanted or not. So now I'm getting the enumerator. So the enumerator, as I say, is the engine that runs underneath the surface of the enumerable. And from that, I'm calling any, which is another one of my classes, which I'll get in my functions I'll get to in a minute. But what we're doing is hand cranking a custom behavior when enumerating through this array. So an enumerator, when you first initialize it, defaults to position -1. -1 being before the start of the array at all. So we always have to start by calling move next. Move next will move it from position -1 to position 0. And move next always returns true or false. True means there was a value, false means there wasn't. And here I'm just mapping it because I'm too lazy to write brackets and things. But all I'm saying is pass this into another any, which I'll explain in a sec. And I'm taking this to pass that down the next line of the chain. I'm passing my function down. And what I'm doing is I am grabbing this .current. So this .current is the first item in the array. So what that means is I've got the first item out of the array, but I still haven't started really iterating it. I'm sort of stuffing that in my pocket to keep it on one side. And then this is the actual enumerator engine that I'm writing. So bearing in mind that we've already moved to position 0 and we've grabbed the first item. So now we're going to move next. So move next will move us from position 0 to position 1, if there is one. Now this is where these question marks come in, because if we have reached the end, then this will return false. This isn't any. So if the move next returns false, or we haven't found any conditions that satisfy the any, then we return false because clearly nothing matched it. And now I'll actually call f, the function that was passed into me by the user. And the previous was the value here. This is where the position 0 item that I stuffed in my pocket. I'm now going to pull it out and I'm going to pop it into f along with the new current. So then whatever comes out of f, whatever the user says they want to do, checking these two consecutive adjacent values, we're going to say, if that was true, then the whole thing can now return true because whatever condition it is, we found one. Otherwise, we're going to call ourselves again, this time using the new this.current passed in as to be the previous value the next time we call this. And then again, passing these back. So we're looping through the array now, kind of skipping over the first item and holding it in reserve. And then we're kind of doing a juggling act where we're skipping the current to previous with each call, so that we can always see the item that's currently the one we've iterated to and the one that was before it. So my contains consecutive numbers function can just look like this. It's my any, an x and a y, which is the pre-value and the current value. And I'm saying something like, if y equals x plus 1, then they're consecutive. I know there's some holes in this code, but it's basically pretty fine. So we don't have to force a to array. And we can just leave this thing unenumerated until the moment where we actually need to know this value. So use of attributes. This is a little bit of meta programming, and attributes are something which don't get used all that much, but they can be used very effectively to reduce the amount of code that you write. So this is a bit of episode data on, once again, Doctor Who, which is the best. And this is some hypothetical CSV data on the ratings and the order of episodes of the most recent series of Doctor Who, that being, I think, number 12. And we want to write something that's going to parse this. So we'll split on new line, we'll select out those guys to array, and then we're going to select again based on position, the item at position 1 being called the title. The season is hard-coded at 11. The number of episodes is hard-coded at 1 because that's the way the new series works. And the writer is whatever's at position 3. So that's fine. But then we look back at the episode data for series 11. and we notice that the format is not entirely the same. There is an extra column here, position 1, which is the overall number of episode of the entirety of Doctor Who ever since 1963, because someone thought it was important at some point. But the point is that that's thrown off our order. So now we've got two different funcs, which just 1 second. Sorry, daughter invasion. Right, so sorry. So now this is one method which is not too shabby. We've got an array of a dictionary, which is taking our season as an enum, and then based on that, we're getting out a func. That's not too bad. I could walk away with that as it stands, but I think we could still reduce down yet further the amount of code we're writing. And that's how we call it. We just sort of, yeah, that's fine. That's fine. There's nothing wrong with this. We're, yes, Pete's giving an example of the exact sort of same in daughter invasions he's getting. Right. What we could use is attributes. So you can create your own these days. I think it used to be a lot more complicated back in the old days, I swear. But these days, it's pretty simple to get an attribute created. You just literally inherit from attribute. And I'm going to say that season number now is an attribute. And that just takes a single parameter, which is an integer, is the number of the season, and it has a single property, which is that, and the CSV position of whatever the heck it is. And that is the position within the CSV that this property belongs to. So then we can convert our episode data into something like this. So we've got our standard set of episode data here as an abstract. So I'm saying you must implement an instance of this. But then in the implemented version, you're putting in the specifics of what you need to override. So I'm now saying season number is hard-coded to be 11 here, and then hard-coded to be 12 there. I'm saying that the CSV position of title is 1 in season 11 and 2 in season 12. And I'm doing it through attributes. And you can write a funny little extension method like this to grab the value out of an extension method without needing to write it lots of times. So I'm attaching to a type, and of that type, I'm saying get the custom attributes. True just means respect inheritance, I believe. Get the first or default, which matches the type, and the type is, oh, that should probably be a T, season number, and map that to be an as. Yeah, just imagine that's a T, and then we get the season out of it. Oh, no, it is get season number. So yeah, that's fine. So we're getting the season number and then default it to 0. We can make an entirely generic one there called get attribute int, where T is whatever the heck type we're trying to get out. So we'll tell it which attribute it is there, and then it will go away, get that type, and then return it back as the correct typed item. If you want to go and get the attribute of a property, you have to write an awful lot more code to do that. But again, I'm stuffing all of this stuff into an extension method so that we don't need to bother to think about this every single time, because I really don't want to have to keep all this stuff in my head. But we have to turn our func into an expression. We have to use the expression as a member expression. What we're doing is actually converting our arrow function that we're calling from the outside world into something that we can pull apart and use bits from to determine which property of you're trying to get out. Yeah, just take this code as a bit of boilerplate and you're fine. But the long and short is that what you get out is this. We've now got a completely generic episode data parser. The T here is an episode data type. So here we would say something like season 12 or whatever. I'm doing my split on new line. I'm doing my select to force them to be array. And I'm doing my select. And I'm using these get attribute ints and get attribute int props that I created to query the attributes out of the class and get the data I really care about. So for season, I'm now going away to the season number attribute attached to the class, getting that, and whatever the heck that is, In here, I'm just calling out the .season property and then popping it in there. And again, for the title, I'm going away to the property. I'm telling it its CSV position I want as the attribute. I'm telling it which property it is I want from that, and then I'm getting out where it should go. That's an awful lot of code, but we only have to write this once. So no matter how far back we go, even if I go all the way back now to season 10 to get the data out of that, all I actually have to do to write my season 10 parser, which has got some funky format again, let's say, is make sure that I attach the correct season number up the top here. And then I can just use CSV positions here so that whatever format all the rest take, I don't need to mess around with metadatas again. I don't need to mess around with writing parsers again. I literally just need to make sure that the attributes all line up and have the correct position values in them. And it's really easy to see what it's doing and how to maintain it. We could even go to the extent of writing additional attributes that tell it what are the line delimiters for lines, what are the field delimiters. So I pretty much never have to write another parser again with any variation in it whatsoever for the whole time that I'm writing these various different season format CSVs, because all of the things that change are now contained in the attributes. And I've written one fairly ugly block of code to do this extremely generic operation. But that's it. From then on, for the maintenance period of this thing, it's all plain sailing. You don't have to put very much effort in once you've done that initial development effort. And rest. So at this point, does anybody have any questions?
I've unmuted you all, so feel free to shout.
First off, I am already married. It's very flattering. But okay, stop that share. Turn on. How do we turn on? There we go. Ooh, hello, folks. I'm back.
Anyway, I can spotlight you as well, and that's you there, look, and that.
Hello, hello, folks.
There it is. I probably should have done that for Stuart earlier as well. Apologies, Stuart.
Sorry.
Whenever I watch any of your talks, and now I've added Stuart to that list, I feel stupid afterwards because that's a lot of stuff I didn't know about.
Cheers. Hopefully useful. One of the questions I usually get asked is, will I put my slides anywhere? But just to preempt that one, I will pop them onto Twitter later on, and I'm sure Pete will do a good job of sharing them around. So for sure, yeah, slides. If anyone had, no worries if no one has any others, but if anyone does have any questions, do speak now or forever hold your peace.
Oh, I have one. I think I saw an older version of this, or it was a different talk, but same topic. And I asked you this at that talk as well, which is what's your feelings on F#?
Hey, I get this one at surprisingly regular intervals. Okay, my feelings on F# are as follows. First off, I have dabbled in it very slightly. It seems very nice. I quite liked it. I liked how compact it is. I like how much more testable it is in many ways than C#. It seems to enforce an awful lot of very good practices in terms of code structure. This is all great. The only problem I have with F# is if you're going to be using it in production, then not only does everyone on the team have to be on board with running it in production, but on top of that, you have to be sure that you're going to be bringing more people in who are either going to be either already know F# or are going to be happy learning it. And I'm not saying that's not a worthwhile endeavor, but this is the real world, and I know what real developers can be like sometimes. So that would leave me a little bit reluctant to actually use F# in production, unless I was really sure that the team was excited for it. But at least with some of the approaches I've put forward here, you can use an awful lot of those sort of goodies that F# gives you, but in C# itself. I mean, if your team is entirely on board with F#, then go for it, by all means. It looks pretty awesome. But I'm making do with what I'm sure that everyone will tend to be would be happy to use in the meantime. Does that answer your question?
Yeah, very good answer, yeah. Thank you.
Any more for any more?
Everyone's learning, you see. Now, I did draw just a minute ago the winner of the JetBrains license. I tried to actually draw it in my browser, but it doesn't work. But it does work on my phone, which doesn't help when you're trying to share your phone. But I can spotlight me, and will it even let me hold this up? There. Can you see what that says at the bottom? That's Chris Cope.
Okay.
So I don't know if that's the Chris I can see in.
I am.
There you are then.
Fantastic.
So,
Thanks, Pete.
no worries. So follow me at Pete_codes, at Pete_codes in the chat window there, and I will send you the license code across. That will get you any single product for 12 months from the JetBrains suite of products. If you don't know what they are, they make developer tools for developers. Awesome stuff like Rider, which in fact Stuart was using earlier, or ReSharper or WebStorm, PHP Storm, any of those good things. So you get to choose one of those. So thank you to them for that. Unfortunately, I can't give you stickers from Stickers because, social distancing. But when we get going again, I will distribute those again now that I've got them back from Andrew of Tech Nottingham, Andrew. So just before we go, has anybody got any final questions? Anything anybody wants to know? Do it now. No, everyone's happy. So thanks again. We should be up and running with Penny and Steve of the Talks Code variety next month, this time next month. So I'll do the same thing and send out tweets, and the password will be in your Meetup messages, and we'll go from there. But thanks to everybody. Thanks very much to our speakers, Stuart and Simon. We'd normally do a round of applause, but that sounds horrible on Zoom, so we probably won't do that. But yeah, 2 awesome talks. I'm assuming, Stuart, you're going to put your slides somewhere, are you? Or?
Yeah, I'll put them on Twitter and share them with you. You can share them however you want with the group. But,
Wicked. Yeah, and we'll see you all next month. Thanks very much.
Cheers, folks.
See you later.
Thanks for organising, Pete.
No worries.
Great talk, Simon.
Thank you.
Cheers.